yang Ladies and gentlemen, NICC 2.0 with ACS-UTP will commence shortly. Kindly sit back and relax while waiting for the session to start. To our audiences, while waiting, please scan the QR code to register for the event. Regards, NICC 2.0 ACS-UTP International Student Chapter Committee. As a gentle reminder to our audiences, please scan the QR code to register for the event. Ladies and gentlemen, greetings from American Chemistry University Technology Patronus International Student Chapter. My name is Daniel, and we will be your host for today's event. We are all gathered here today for the NICC in Chemistry Challenge 2.0. Your presence and participation are highly appreciated and anticipated. Before we start off our event, let's invite Muhammad Irfan for the Dua recitation. Please welcome.
Our ceremony will begin with the recitation of Kitab and Al-Fatiha. إلى حضرة النبي المصطفى وعلى آله وصحبه وسلم. الفاتحة. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين. Almighty Allah, thank you for providing us with blessing and benediction, light and guidance, faith and health, peace and tranquility, and this opportunity for us to assemble today in the ACS-UTP NICC in Chemistry Challenge 2022. O Allah, we implore you to keep a close watch on this ceremony and gaze on it with grace and mercy. O Allah, the most merciful of all, please grant us the following constancy in faith, knowledge and wisdom, physical well-being and strength, generosity and virtue, and the ease and facility with which we can acquire knowledge that will be beneficial to this around us and to mankind as and may it bring blessing in this world and the next. اللهم إنك تعلم أن هذه القلوب قد اجتمعت على محبتك والتقت على طاعتك وتوحدت على دعوتك وتعاهدت على نشرة الشريعة فوثق اللهم رابطتها وأدم ودها واهلها سبلها واملاها بنورك الذي لا يخفو واشرح صدورها بفيض الإيمان بك وجميع التوكل عليك وأبيها بمعرفتك وأمسها على شهادتك في سبيلك إنك نعم المولى ونعم النصير. Once more we pray that you bless and mercy our family and lead and guide us in pursuing our dreams, in performing our obligation, and in living up to the hopes and expectation of our family, faith, and nation. And our prayer and forgive our sin as well as the sin of our parents and those who will believe in you. ربنا آتنا في الدنيا حسنة وفي الآخرة وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Amin, amin, ya rabbal alamin. Thank you, Muhammad Irfan, for the wonderful dua recitation. Avila, are you ready to start the ceremony?
Yes, of course. Hello, everyone. First of all, praise to God for giving us the chance together today in this program. Originally, this is a frame of reference on why our event is titled NICC 2.0. NICC is the short form for Next in Chemistry Challenge program that is held for the second time. This program aims to promote innovativeness among the undergraduate and postgraduate students in Southeast Asia region as well as around the world. The competition is in conjunction of celebrating the National Chemistry Week, which is a public awareness campaign to promote the value of chemistry in everyday life. And ICC 2.0 is different compared to the past year event, which is also in conjunction with the celebration of 25th anniversary of University Technology Petronas.
Thank you, Avella, for the lovely remarks. Now let us invite the chair of ACS Malaysia, Dr. Muhammad Suko Said, to give his welcoming speech. Please welcome.
Bismillahirrahmanirrahim. To Honorable Guest, Professor IR Dr. Hilmi Mukhtar, Deputy Vice Chancellor, University Technology Petronas, Associate Professor Dr. Cecilia Devi Wilfred, Advisor of American Chemical Society UTP Student Chapter, Chairperson of American Chemical Society UTP Student Chapter, Ms. Anis Izana binti Rusli, participant of ACS-UTP NICC in Chemistry Challenge 2.0, respective representative from universities, distinguished guests, and students. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh and very good morning to all. Very warm greeting to all here for the NICC in Chemistry Challenge 2.0 in conjunction with ACS National Chemistry Week 2002. I'm more than grateful to be here and welcome you all to this event on behalf of the American Chemical Society Malaysia chapter. First and foremost, I would like to thanks to ACS-UTP for organizing the NICC 2.0 with the theme Polymer Fiber is in line with National Chemistry Weeks this year. The competition aims to develop and nurture the potential of young scientists and promote innovativeness in the field of chemistry science among the students from all over the world. Ladies and gentlemen, this event is in line with ACS Malaysian vision, and we are keen to support this kind of project related to capacity building, outreach program, and networking. With your continuous effort, we'll to do something for our society and move up towards a successful and fulfilling world. A great amount of credit goes to organizer and all parties involved for making this event a success. To the participants, I would like to take this opportunity to acknowledge you for the commitment, dedication, and passion for this event. I look forward to listening to your creative point of view in the latest session. All in all, we could not done this without you. Lastly, I wish all the best. I believe that NICC 2.0 will provide an inspiring and innovative platform for all, and few hours will be enjoyable and fruitful for every of you. Good luck to all the participants, and I wish ACS UTP NICC 2.0 a huge success. Thank you so much.
Thank you, Dr. Muhammad Suku Said, for the wonderful speech. Consequently, let us invite the Dean of Faculty of Science and Information Technology, University Technology Petronas, Associate Professor Dr. Jafrizal Jafar, to give his speech. Please welcome.
Thank you, MCs, for the invitation. Bismillahirrahmanirrahim. Dr. Syukur Syuaib, Chair, American Chemistry Society, Malaysian Chapter. Associate Professor Dr. Cecilia Devi Wilfred, Advisor of American Chemical Society, UTP Student Chapter. Chair Anis Izana Rusli, Chairperson of American Chemical Society, UTP Student Chapter. Participants of ACS-UTP NICC in Chemistry Challenge 2.0, respected representatives of university, beloved students, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and very good morning to all. On behalf of University Technology Petronas and Deputy Vice Chancellor Academy, it is a pleasure to me to have everyone here for the American Chemical Society ACS-UTP International Student Chapter NICC in Chemistry Challenge 2.0 in conjunction with National Chemistry Week 2022 and theme Polymer and Fiber. The ACS-UTP and NICC 2.0 is a platform to stretch and challenge students in the shared area of chemistry. This time around, we will be focusing on polymer and fiber that would open new opportunity for the development of experimental and theoretical techniques and finding new perspective of their applications. In UTP, under Fundamental and Applied Science Department and the Center for Student Development, UTP value educational experience and opportunity that enhance academic success and enrich student experience in the university. Thus, it is important to leverage on activities and events like this where all of us around Malaysia can connect, exchange knowledge, and present innovative idea in relation to chemical science for continuous advancement in the field of chemistry. Not only that, but we also need challenge like this to nurture our mind to all the possibilities and opportunities offered by the studies and appreciations of science, technology, engineering, mathematics, or STEM. Ladies and gentlemen, challenge such as this is commendable to create learning environment for students in strengthening their knowledge in chemistry. We need to make use of all our multidisciplinary expertise and academic resource and synergize with university know-how to debate and discuss on how to best understand pressing issues in chemistry. Hopefully, event like this can be the bridge to address this need for more improved understanding on several fundamental aspects of chemistry. It is the time now to innovate, else we will perish. The pandemic has shown to us the importance of being ahead of technology games. Hence, I am imploring to all to not just to have a good grasp of your knowledge in chemistry, but also in a good understanding and engaging technology and their impact. And applause to use of social media in the challenge promoting technology as an enabler. This is imperative for us future scientists. We need to always upskill and reskill to meet current and future workforce requirement and ensure we are marketable and capable to doing actual work in today's industrial scenario. Back in 2019, UTP staff Dr. Margaret Sivapragazam became the first Malaysian selected for the prestigious periodic table Younger Chemist by the International Union of Pure and Applied Chemistry, IUPAC. Dr. Margaret was selected for her representations of ytterbium, the 70th chemical element in the periodic table. I'm confident that among of us today will be seeing the next Dr. Margaret. Ladies and gentlemen, before I end my speech, I would like to express my heartiest appreciations to Dr. Muhammad Syukur Syuaib from ACS Malaysian Chapter, Associate Professor Dr. Cecilia Devi Wilfred from ACS-UTP Student Chapter, the organizing committee, as well as all participants for the commitment and dedications in ensuring the success of this event. Congratulations to all final participants of ACS-UTP NICC 2.0. Without further ado, and with Bismillahirrahmanirrahim, in the name of Allah, more gracious, more merciful, it is give me a great pleasure to officiate the next in Chemistry Challenge 2.0 NICC 2.0. May all of you experience the most wonderful time during this event. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
For officiating our event. Bringing the theme of polymers fibers, there are several chosen finalists that will be presenting their topics in the judging session. So Daniel, can you share more details about this?
Sure, Avella. The selected finalists will present their topic for 10 minutes, and there are 10 finalists from the undergraduate category and 7 finalists from the postgraduate category. The finalists will be separated to 2 meeting rooms following your category. Good luck to all of you.
Everyone,
Good morning, everybody. So as of now, we are still waiting for the rest of the participants to be assigned into this breakout room. So we will start our presentation for you undergraduate category on 9:20 a.m. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. Our session will begin in 10 minutes. Hopefully to all the presenter, please be ready with your presentation and also for the Q&A session. Thank you.
For 25 years, UTP has played a significant role in taking the nation, industry, and society forward. As we eye a greater shared future, our graduates, stakeholders, and community are in line to be the makers that push reality-defying growth and innovation. Welcome to our 25-year story of energizing futures. As a result of our 25-year experience, our well-rounded graduates and global citizens embrace the power of initiative to excel in the most demanding atmosphere of integrity, accountability, and innovation. Everywhere around the world, UTPians pave their success by making meaningful contribution to global industries as leaders of current trends. Based by our strong industry network, this gives UTPians a competitive advantage that gets them career ready even before they graduate.
UTP gave me the opportunity to really test myself and expand my horizons. Through my experience in UTP, I organized multiple volunteerism events, one of which even took place in Vietnam. From the moment you join UTP to the day that you graduate, that experience is one that will benefit you. It will change you as a person, whether you're a student or whether you're a staff. And these experiences give you lessons that will be embedded in you throughout your whole life, hence UTP in me.
As the world moves rapidly, UTP strives to be a leader in technology and education, as well as a center of excellence for creativity and innovation.
I think the most memorable experience is how we, the students, work with the lecturers and staff to pioneer new things. During my time, there was no clubs or student activities yet. So we started organizing activities, setting up clubs, and so on. We built the platform together, so to speak. Those are invaluable experience for me. When you don't have it, create it.
Research and development, R&D, is one of UTP's flagship core drivers. It has become a familiar hallmark of progress and prestige for the university. For 25 years, UTP's R&D activities have constantly returned many tangible benefits to the nation, industry, and society.
When you have that 8-month period, companies and also the leadership team of that place where you're interning in are more likely to give you projects. So everywhere I've gone, they all say, wow, UTP internship program, #1, the best. And I agree. Without that 8 months exposure, I do not think I could have as easily, I wouldn't have been as ready for the industry right after graduation. And just to share, less than 1 month after my graduation, I did manage to secure a job as a reservoir engineer at ExxonMobil. And what the feedback that I got was that, it seemed that I was very prepared to join and work and contribute to a corporation and to an organization. And I don't think I would have been able to do that without that industrial experience.
I would like to wish happy anniversary UTP, and thank you for all these amazing 5 years and for all the opportunities and chances that you have given me.
Since our inception in 1997, UTP is committed to fostering collaborations and partnerships with the industry. Together with our partners, we edge towards sustainable global prominence, a unique feature of our global prosperity action and identity.
UTP is not just a classroom, but a real-life, career-integrated learning environment. It allowed me to explore what is a true potential within me.
I am glad that I managed to continue my passion in rugby sports that I've played since I was 16 years old and became the team captain for UTP G Drillers Rugby Club.
From organizing the event, being the MC in the concert hall, leading the International Student Representative Council, managing a football team, forming a music band with friends and competing at the national level, to representing the university for the Petroleum Engineering Quiz competition. Who would believe that it all would happen in just a few years in UTP?
When we developed this university some 25 plus years ago, we call it a dream. The dream was to have the best engineering school in this part of the world, to produce students with holistic education so that they can contribute to the future success of themselves, their careers, and ultimately to the global good of the world. So it was a big dream, and the dream continues. Let's carry on with the good work. Let's continue with all the things that we believe in, and God willing, success will be achieved.
At UTP, unlocking true potential is one of the major life possibilities that we seek to create. In this respect, we will continue to sustain our unwavering efforts in producing relentless, creative, and innovative graduates. Thank you for being part of our journey. Here's to more years of energizing futures.
Applied chemistry is in our everyday lives. We see chemistry in almost everything. For example, the air we breathe, the food we eat, and even the fuel that powers up our cars. Chemistry is important because we see it in our everyday lives, and everything we observe is due to chemical reactions. My best UTP experience, I developed a catalyst to convert carbon dioxide into methane. And aside from my FYP project, I also managed to lead student organizations such as the Society of Petroleum Engineers student chapter, where I was elected the deputy vice president.
I did my 7 months of internship at Japan. The experience is really great. I'm doing the research is regarding about the deep utility solvents using as a catalyst or as a co-solvents as well to enhancing the biodiesel production.
Chemistry is an important part in any future industry. Thanks to UTP's strong industrial linkages, as well as the wide range of expertise, I can apply what I've learned in the industry.
Backed by strong ties with Petronas, the parent company of UTP, the graduates from this program is able to tap onto that opportunity and enter into the oil and gas industry in Malaysia. The content of the program allows some level of versatility for the graduates to explore beyond the oil and gas industry in Malaysia. So it pushes the boundary to explore all other job options available in the country and also regionally and so internationally. So that makes the UTP graduates high-value graduates.
As you know, in our applied chemistry course, for the first 3 years, the student will be doing fundamental chemistry. They also will be doing some computational chemistry. So after the 3 years, they will do a specialization package where they can do research projects. So in this research project, they can do either in environmental, they can do in catalysis, they can come up with new materials that can reduce pollution. After they have done this research, we believe this will equip them to go into the job market. In Malaysia, a lot of companies are looking into chemistry who has knowledge in this area. So we believe in UTP, we will prepare the students for this job market that is not only today, but will be useful in future.
UTP Applied Chemistry Program received prestigious accreditation from the Royal Society of Chemistry, or RSC, positioning the program to be internationally recognized. This provides assurance to employer and students in a competitive global job market. The RSC recognition also gives opportunity to students and academic staff. The Mobility in Exchange program among the RSC accredited institutions worldwide. The Applied Chemistry program in UTP also offered 3 specializations, namely petrochemistry, sustainable chemistry, and nanotechnology, to cater for the Industrial 4.0.
The youth is important in Malaysia, and it's very important for us to ensure that they can participate in Malaysian well-being. So besides securing a job, we want to also get the students involved in the nation's issues, especially in environment, in pollution, in coming up with alternative energy. In UTP, we believe our course is preparing the students for these areas. When the students make a discovery in the lab, especially in their final year research project, we ourselves as a lecturer for past 21 years, we feel the honor to see the light in their eyes when they find a discovery. So, and many times these students have made useful discovery, which we are using it for our research project in later years. Coming to UTP is a good step for our youth to take up especially the applied chemistry course which we are offering here. Join us. Together we can dream up new possibilities.
Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi wabarakatuh. Welcome to the breakout room for undergraduate category. I would like to welcome and introduce our honorable judges for today's competition. There are 4 judges today with us who are Assistant Professor Dr. Wipo Sri Subsai, King Mongkut Institute of Technology Lat Kerabang, Dr. Anissa Urrahmah, Universitas Muhammadiyah Surakarta, Ms. Cho Meling, Agilence Technologies Malaysia, and Dr. Stephen Lim, University Tunku Abdul Rahman. All the judges' decisions are final and individual mark are confidentially discussed. Thank you.
Ladies and gentlemen, without further ado, I would like to welcome our very first contestant for today, Polyman from University Technology Malaysia, UTM. Please welcome.
Hi everyone. I believe that most of us have used sponge in our daily life. I mean this kind of sponge. So may I ask you, what are you doing with that sponge after you finish using it? I know that most of us will just throw it into the dustbin.
But I did deserve that!
But let me tell you that that is not a good idea. Alright, I know now some of you are wondering why I make such a statement. Is it wrong to just dispose it? Before I explain the reason, let me explain something about this sponge. More everyday sponge now are derived from a substance we call as polyurethane, which is a type of polymer synthesized from diisocyanate and polyol units composed of urethane links. It has extensive worldwide application, not just as a dishwasher sponge, but also as automobile seats, memory foam cushions, mattresses, and many other usage. For your information, in 2018, as much as 359 million tons of plastic were produced worldwide, and 7.9% of it is made of polyurethane. And due to the high production capacity, for sure, the post-consumer polyurethane waste also will become a lot. Therefore, the idea to dispose of polyurethane-based products conventionally will only let them to end up in the landfill. This is a bad idea, since polyurethane products deposited into landfill decompose into hazardous and environment-damaging substances, and it takes long time to decompose. This can be proven by the picture shown. The appearance of the polyurethane foam before and after being exposed to weather, underwater, and heat aging at 70 degrees Celsius for 2 years. Alright, so it takes long time to degrade. Maybe some of you are thinking, how about we get rid of it by incineration process for energy recovery? Nah, that is another bad idea, since the process will also release numerous hazardous chemicals such as isocyanates, hydrocyanuric acid, and dioxin. So, to overcome this problem, in this video, we are suggesting an alternative way to treat polyurethane waste by recycling it into super oleophilic material for oil absorption purposes, such as cleaning oil spills and oily water waste treatment. The procedure of this super oleophilic material was cited from the article here. The first step is immersing polyurethane foam in the chromic acid solution, followed by ultrasonic washing in distilled water and ethanol to remove surface stains and oil. The second step is immersing polyurethane foam in the ethanol solution that contains iron oxide powder to increase roughness for greater absorption capability. The third step is immersing polyurethane foam in the dopamine solution to anchor the iron oxide onto the polyurethane surface. And lastly, the polyurethane foam is deep coated in the fast 70 solution to induce the super hydrophobic transformation. There are a lot of advantages of this recycled polyurethane. Not just capable to absorb oil, but it is also low cost to manufacture. Not only that, but it is also stable toward corrosive liquid and can be used in more complex environments such as in acidic solution, basic solution, and also in the simulated seawater. This proof is also being mentioned in the articles This diagram shows the high absorption capacity of oils in those three different conditions. Next, it is also reusable. From the graph, it is shown that the absorbent capacity of the magnetic polyurethane sponge remains almost unchanged even after 10 cycles, providing proof that the product is reusable and can have a long lifespan. Lastly, there is no harsh or sophisticated procedure to create this product, which give great potential to bring this product for commercial application and big-scale manufacturing.
Due to the oleophilic nature of this recycled polyurethane material, we believe that one of its biggest applications will be the oleophilic disc in the oil skimmer. The oil skimmer is a device for recovering oil from the water surface, and the disc is typically made from PVC, steel, or aluminium. Thus, in contrast to the material mentioned just now, this recycled oleophilic polyurethane material could be the new sustainable source of material to make the disc of the oil skimmer.
Based on our observation, there are many types of oil skimmer in the market. So, assuming that we want to build a disc skimmer, let's estimate the cost of chemical to build a cylinder oleophilic disc with a radius of 1 meter and a height of 0.1 meter. So, here are the disclaimers on our method to estimate the cost. First, the requirement amount of chemical is calculated just by simply scaling up according to our literature review on the production of 5 times 10 times 10 millimeter oleophilic polyurethane. Secondly, the price of the chemical used in the washing process are neglected. Based on our calculation, the cost will be 2,692 ringgit 2 cents. I know it seems really expensive just for one disc. However, if you look closely at the procedure, you will notice that all of the chemicals are actually used by just deep coating with the polyurethane. So, the chemical actually can be reused for the consecutive productions. And with the economy of scale, the cost is expected to be lower in the large-scale production. Our whole idea was strongly inspired by this article written by Henan University in China and the recycled newspaper pencil. In the article, researchers produced and characterized 5 times 10 times 10 millimeter magnetic oleophilic polyurethane solvent. This magnetic oil solvent was actually intended to be used by applying and recollecting the solvent with a magnet, since you know the solvent is magnetic after all. However, this approach could be impractical to treat large-scale oil spill in the ocean, based on Dr. Suzanne, who was the founder of Marine Environmental Research Institute. Therefore, our team wondered, instead of using this magnetic recollecting method, why don't we just use the solvent as part of the oil skimmer? Since oil skimming is actually a method that has stood the test of time and has been proven to be reliable in treating ocean oil spilling. So, integrating this oleophilic polyurethane solvent into the pre-existing oil skimmer was our initial prototype. So, this was our first inspiration. Here comes our second inspiration, recycled newspaper pencil. To produce recycled newspaper pencil, the manufacturer recycle all newspaper into the skeleton that support and protect the lid inside the pencil. We found that this relationship between the recycled newspaper and the pencil lid is actually quite similar to the relationship between polyurethane and oleophilic chemical substance. Similar to the structure of newspaper pencil, the polyurethane is actually just the skeleton to hold all the hydrophobic chemicals that can absorb the oils. Therefore, the invention of recycled newspaper made us wonder, could be the polyurethane skeleton be made from recycled material, just like how newspaper pencils are made? And other than using new polyurethane material for the skeleton of the oil solvent, could we just recycle polyurethane waste into the skeleton of the oil solvent instead? So these were our overall thought process. In the end, we come out with the idea of recycle polyurethane waste into super oleophilic solvent in the oil skimmer. Polyurethane waste is a big waste problem, just like how my buddy Habil explained just now. So by recycling polyurethane waste into super oleophilic material, we can not only reduce the problematic polyurethane waste in the landfill, but we can also provide another sustainable source of material to build the oil skimmer that can save countless lives from oil pollution. Let's fight pollution with pollutant. Thank you for watching.
Thank you so much to Team Polyman for your wonderful presentation on this topic. Now, I would like to open the floor to the judges for any questions and comments. A gentle reminder, Q&A session is limited to only 10 minutes. Please welcome.
Hello, good morning. Can you guys hear my voice?
Yes, perfectly.
Okay, maybe I'll start the Q&A session first. Okay, so I'm Steven. Hi. I think that the idea of converting this waste polyurethane into the oil skimmer is a very interesting concept. So I think it's a very good initiative and very innovation. So I have one question. So after the waste polyurethane that you have created absorb all these oils and hydrocarbons inside. So is there any efficient way to remove it so that after that you can reuse it again? Have you think about this after the process?
All right. Thank you, Dr. Steven, for the question. And yes, it's actually like what we can actually because it's an oil skimmer, right? So of course we need to separate the oil from after we absorb it, and we can use the skimmer as a compressor to remove back or to extract back the oil that we absorb. It's like like using the normal sponge. As a daily usage, we absorb water, right? But instead of absorbing water, this material that we created absorbing oil. So we can just extracting out the oil by squeezing or compressing it to extract the oil out for further processing.
Okay, how much? Yeah, do you have an idea how much you can remove using the squeezing method?
Wait, actually, if you want to say about how much oil that we can extract, because okay, so you can go. My friend will answer for this.
Okay. Good morning, Judge. So based on one article we read online, actually like one oil skimmer, it actually can recover 4,700 gallons of oil per minute. I'm not because oil skimmer can because there are many types of oil skimmer in the market. So I believe that every oil skimmer can absorb and recover different amount of oil, but based on this article, it says that it can recover 4,700 gallons of oil per minute. So I hope this can answer your question. Thank you.
Yeah, thanks for explanations. Yeah, I'll pass to the rest of the panel. Thank you.
Thank you, Dr. Steven. Can we move to perhaps Dr. Anissa?
Yes, I forgot to unmute. I'm so sorry. Okay, I have a simple question. Yeah. The first is, what is the difference in the terms of chemical characteristic? As you mentioned earlier, it is you have a magnetic PU and, for example, with the non-magnetic polyurethane. What is the difference in terms of their oil absorption capacities? Yeah? And then the second one is you mentioned that the material that you will be produced will have higher economical value compared to the commercial one gitu. have you ever survey about the value of the one, the value of the commercial wine compared to the material that you are going to develop? Okay, that would be all. Thank you.
Okay, so thank you, Judge, for the question. So I would like to answer for the first question. The first question I think is how the magnetic properties actually helps the polyurethane, right? In terms of absorption capability, is that right? Okay, okay. So actually, in terms of magnetic properties, the original article we read, they actually wants to use it in the way that they just apply the oil sorbent on the water surface, and then they just recollecting every oil sorbent by using just magnet. So that's why they want the oil sorbent to have magnetic properties. But actually, the reason they can have magnetic properties is because they anchor some iron oxide onto the surface of the polyurethane. But the iron oxide, they can not only provide some kind of magnetic properties, they actually also provide, they also actually increase the roughness of the polyurethane, and then eventually it can also increase the absorption capacity. So you may wonder why do we need to have magnetic properties? Actually, in our proposal, the magnetic property actually serve no purpose in our oil sorbent. It's just that the initial prototype designed by those researchers, they just want it to have magnetic properties, but as we mentioned in the video, the applying and recalling method using the magnet is actually not very practical in the real life, in the large scale oil pollution. We want to treat large scale oil pollution, but why do we want to still remain these magnetic properties in our polyurethane? Is because it actually also provide, because we still want to have that roughness and high absorption capacity of the polyurethane because of the iron oxide that is anchored on the surface of the polyurethane foam. I hope this answered the first question. Thank you, Judge.
Okay, about the second question, it's about comparing our product with the commercial one, right? So the difference between what we do is we try to convert waste to oil skimmer instead of what they created in the commercial oil skimmer. They are using, and of course, over time, the new skimmers, we need to replace it, and of course, I did search it online, and the oil skimmer, is it like a disc or a belt? It costs more than what we expect. So by converting the waste, polyurethane waste, we can actually reduce the cost of making this oil skimmer. So we can make it available and affordable for everyone to use this oil skimmer in the future. And of course, I hope that in the future we can deal with oil spill problems and oil waste treatment, especially for oil water treatment. I think that is it answering your question.
Thank you.
You're welcome.
Apologize
thank you.
for
I'll
this.
pass to the other judges.
Apologize to Associate Professor Wipo as well as Ms. Cho Mi-Ling, as we are with a time constraint, but there shall be a maximum 3 questions only for each group, so we may have to proceed to another group, and we will give the questions for the next group, for the next team to Dr. Associate Professor Wipo and also Ms. Cho Miling, if it is okay with both of you.
Okay, all right. That's okay.
Thank you,
No
and
problem.
I'm
Yeah.
sorry.
Thank you so much, all judges, for the question. Appreciate it.
Okay, thank you for your presentation.
Welcome.
Thank you.
Ladies and gentlemen, to all participants, please make sure to double check your webcam as well as your microphone before the Q&A session started. To the judges, a kind reminder that for each Q&A session, there shall be maximum 3 or 4 questions limited to 10 minutes as we are facing a time constraint. Thank you.
Thank you so much for all the feedback and questions from the judges. We are done with the Q&A session for the Parliaments group. Now, let's move on to the next group, the Dimers from University Technology Petronas, UTP. Please welcome.
Hi, my name is Marcella Maggie, currently taking Bachelor of Science in Applied Chemistry at University Technology Petronas.
Hello everyone, my name is Sita Govinayar from Applied Chemistry course from University Technology Petronas. Organic polymer solar cell is a type of solar cell where the absorbing layer is made up of organic semiconductors such as polymers. There are a few characteristics of organic polymer solar cells, which are: it is solution processable, has tunable electronic properties, requires low temperature for manufacturing, and it's made up of cheap and light materials. There are a few advantages of organic polymer solar cells, which are lower material toxicity, low cost, and lesser environmental impact. Up to the current date, organic polymer solar cell has exceeded efficiency of 13%, which is close to efficiency values obtained by low-cost commercial silicon solar cells. Although it has its own advantages, there are few limitations in the current organic polymer solar cell, which are: maximum efficiency that could be obtained is 30%, and the use of halogenated as well as chlorinated solvent in fabrication has the capability to affect the environment negatively. Therefore, our research will be exploring on the use of green solvent in the fabrication process, as well as study on the efficiency of the cell. Moving on to the problem statement of this research, which are: the usage of hazardous solvent in polymer solar cells has contributed to environmental pollution. Secondly, the cost and high energy requirement for the production has limited the manufacturing of polymer solar cells. Last but not the least, the power conversion efficiency of polymer solar cells using harmful solvent is lower than the eco-friendly polymer solar cell. There are 3 objectives which are likely to be achieved from this research, which are: to investigate how organic solar cells could reduce the environmental pollution, and to determine the solvent and material which could reduce the cost and energy needed to produce eco-friendly polymer solar cell. Last but not the least, to study the power conversion efficiency of eco-friendly polymer solar cells. Next, let's take a look at the methodology of this research. So, what is organic polymer solar cell made up of? To answer the question, let's take a look at the diagram. As observed, the top layer of the cell is made up of ITO class, or also known as indium tin oxide class, where it is coated with either indium or tin oxide, which act as the anode of the cells. Consequently, the whole transport layer is made up of poly-3,4-ethylene dioxythiophene polystyrene sulfonate, and the electron transport layer is made up of calcium. Meanwhile, the bottom electrode is made up of aluminium, where it acts as the cathode. Lastly, the active layer consists of donor layer and acceptor layer, which is made up of conjugated polymers, as well as uses green solvent such as water, alcohol, non-halogen and chlorine-free solvent to produce an eco-friendlier polymer. Here, aid in the mobility carrier charge and electrons into polymer solar cell. In addition, there is a research conducted on how to save the cost of production of polythiophene or 6,7-difluoro-2,2-hexydicyclooxyquinozoline, or also known as PTQ10 polymer, which is one of the polymers widely used in the active layer of the cell. The synthesis of PTQ10 polymer involves a simple molecule. Although the steps involved in this synthesis are longer, as shown in the diagram, it is proven to save the cost of production by 86%. Not only that, but studies also show that it is processable with green solvent to give higher efficiency of energy. Now, let's take a look on how does organic polymer solar cell work. Firstly, the conjugated polymer absorbs light and generates exciton, which is bonded electron hole pairs. This exciton will then be dissociated into free carriers in donor and acceptor interface, followed by migration into charge extraction and transporting material. Next, the free charge carriers, holes, and electrons will be collected at the anode and cathode respectively. Lastly, the free charge carrier will be transferred to external circuit to convert from light to electrical energy.
So, we have taken a look at the procedures taken to make the solar panels. Now, we would like to discuss about the expected results from this project. First and foremost is the capacity for this new solar panel. It is estimated to be 9% more than conventional solar panels, which means that this solar panel will be able to store much more energy. Next, let's talk about the size of this solar panel. The dimensions is expected to be 20 inches in width and 12 inches in height, while the weight is about 9 kilograms. This is about as heavy and as big as a 24-inch computer monitor. The price for this conjugated polymer solar panels is expected to be much lower than the current market price. This is because the advancement in the synthesis has allowed an 86% reduction in material cost. In terms of its effect to the environment, this conjugated polymer is expected to be more environmentally friendly since it uses an organic solvent in comparison to the common solar panels which use toxic solvents. Now, let's look into the discussion part of the project outcome. First and foremost, this new design, material and processes have a fabrication rate of over 95%. This means that almost all devices were able to be created without any short circuit in the fabrication process. This is extremely important to scale up the fabrication to an industrial level. Next, it is found that conjugated polymer solar panels can be easily personalized to any feature that we want. This is due to the fact that polymer itself is very highly customizable. Other than that, these solar panels are easily reproducible and rapidly manufacturable thanks to solution printing, which is the method used to print newspapers. Last but certainly not least is the fact that this new solar panel produces the use of renewable energy. This is due to the fact that it is highly efficient while also being good for the environment and at a cost that is low enough that it is easily accessible for most people. Finally, moving on to the conclusion of this project, we found that the use of conjugated polymers in the process of making solar panels has three main benefits. Firstly is that it is better for the environment. This is due to the fact that we use organic solvents instead of toxic ones. Secondly is that these conjugated polymer solar panels can offer a lower cost. This is due to the fact that we use much less energy in the manufacturing process and also the advancement in synthesis of raw materials. The third and final benefit is that it is more efficient. This means that the solar panels can convert more of the energy that it receives into usable energy for us consumers. Now, moving on to the impact of this project. First and foremost, we can create a more accessible form of renewable energy thanks to the reduced cost when using these conjugated polymer solar panels. We expected that when using these solar panels, we can have a reduced cost of 0.0% per kilowatt hour of electrical energy. This is 10 cents less than the average of 0.45 ringgit Malaysia per kilowatt hour in Malaysia. Next, the impact of this project to the environment is the fact that these solar panels are more environmentally friendly compared to the ones on the market due to the fact that it uses an organic solvent. The use of organic solvents instead of toxic solvents helps the environment in terms of toxic waste emissions. Moving on to the impact on the performance of the solar panels, we found that these solar panels have an 18% efficiency compared to most solar panels that only have about 50% efficiency. This means that compared to the solar panels on the market, these contributed only solar panels can store 3% more energy and convert it to usable energy, which makes it more efficient. Finally, this project also enables an handling when it comes to these solar panels. This is thanks to the fact that these solar panels are made to be smaller than the average monitor.
How does this organic polymer solar cell has the ability for industrial scale-up? Firstly, it requires low energy in manufacturing organic polymer solar cells since it does not require a lot of heat in the production of the cell. Secondly, the new devices were created with no short circuit during fabrication. Lastly, it has the capability for high efficiency energy without harming the environment since it uses green solvent in the fabrication of organic polymer solar cells.
Thank you so much, Daimer, for your presentation just now. A kind reminder, attention to our audience, please be focused throughout the presentation as there are a lot of new information that might be beneficial for you in the future. Now, I will open the floor to the panel of judges to give their questions and remarks for 10 minutes. Please welcome.
Okay, let me have questions. First off, a very interesting project and your idea about the organic polymer solar cells. Okay, and I think one is very important for solar cell is lifetime. Do you have any idea for the lifetime for the organic polymer solar cells when compared with the traditional solar cells? How long we can use it?
The lifespan of organic polymer solar cell has not been stated so far, but when compared to the traditional organic polymers, traditional solar cell, the lifespan is shorter. But the traditional commercial solar cell they use toxic solvent and they use silicon to fabricate the solar cell, which is harmful to the environment. At the same time, it requires high cost to produce the solar cell. Therefore, this has limited the silicon solar cell in the production and usage to use it as an alternative source instead of fossil fuel in the energy production sector. This organic solar cell uses green solvent in the production, where it requires low cost as well as it does not harm the environment and human life. And moreover, the energy capture from the solar energy, the solar energy capture of organic polymer solar cell is higher compared to this traditional solar cell. Therefore, it has the capability to absorb more solar energy and store it. Although the lifespan is shorter, it is more practical to use this organic solar cell due to the many advantages compared to the traditional solar cell. I hope that has answered first question.
Okay, all right, thank you.
Okay, another question from my side is, I see from your side you mentioned about the efficiency. So can I know, do you have conducted any tests to measure this efficiency?
These efficiency tests were conducted by other researchers. We took it from a journal.
Oh, okay. So on your side, you did not conduct this experiment to prove the concept?
Yes, we used other researchers' knowledge to to the to what is it, to include the information.
Okay, that's all from my side.
Thank you, madam.
Is there any question from other judges? Maybe we can have question from Dr. Anissa Rahman or Dr. Stephen Lim. Is there any question for the timers?
Sorry,
No
Dr.
question for
Steven,
me.
I think you are muted because we cannot hear you on our side.
Associate Professor Dr. Viposi Subsai, do you have any question for the timers?
No, I have no more questions.
All right, thank you, Doctor. Maybe we can wait for a while for Dr. Stephen to check their microphone and asking the question for the timers. Thank
Hello,
you.
can you hear my voice now? Hello?
Okay, yes.
Okay, good. Thank you. Sorry about the technical error just now. My question will be in the usage of these renewable and green materials for the solar cells. So I'm wondering how is it the recyclability of this material? Is it easy to recycle? Because we all know that after certain usage of the solar cells, then it will be disposed as if you have any idea how we can actually recover these materials in a sustainable manner?
Okay, so about the sustainability of the um, organic materials, for now we haven't really found like information about the recyclability of the solvents and the materials itself, but we found that it does not really harm the environment. So we expect it to be during the decomposition of the material itself. We found that that it is not going to release toxic byproducts that could harm the environment. So we expected it to be more sustainable in that way instead of in terms of recyclability. So yeah.
Okay, good. Thanks for the explanations. Thank you. That's all for my side.
Is there any more question from the judges? No, okay. If that's all the question for the timers, thank you so much for the timers. For I will pass to the Batusha for the next group.
Thank you to all the judges for the questions and feedback just now. We will now move on to the next group turnout from University Malaya, UM. Please welcome.
Greetings, I'm Shuhui.
I'm Adam.
We, Team Tenor from University Malaya, would like to present to you Polymer. Based on the 2022 statistical review of world energy by BP, last year, more than 65% of energy resources of all regions came from the fossil fuels, with Asia-Pacific showing a staggering 85%. And by taking a closer look at the energy consumption in Asia-Pacific, coal, oil, and gas covered 92% of the Malaysia's energy consumption. Going deep down into Malaysia's energy consumption by year, the increasing demands of energy calls upon the uprising trend of energy production through various resources. However, fossil fuels are still taking the lead, and the trend of clean renewable energy sources is still lagging. In the future, there should be an increasing demand for clean energy sources to accelerate our energy transitions and encourage the global energy mix.
One promising alternative sources of energy is via the use of piezoelectric material to extract energy from daily mechanical motion. An example of such powerful material is PVDF. However, the energy harvesting performance of conventional PVDF is usually limited. Therefore, we would like to present a high-performance PVDF nanofabric. Through this implementation, we want to achieve 3 Sustainable Development Goals, that is SDG number 7, 11, and 12. With that being said, we'd like to present to you polymer, the polymer of electricity.
So here are the list of methods we'd like to bring out for our project.
We propose to prepare polymer through electrospinning technique. First, PVDF will be dissolved in triethyl phosphate and stirred for 1 hour at 60 degrees Celsius. A typical electrospinning setup consists of 3 compartments: a string, a collecting screen, and a high voltage power supply. Electrospinning, solution, and ambient parameters are controlled to ensure the quality of nanofibers produced. Once everything is fixed, we will close the circuit and our nanofabric is produced.
A PVDF nanofabric works based on the piezoelectric effect. When a mechanical stress, which is represented by the ball, is applied onto the fabric, electrical energy will be produced. Down to atomic scale, the mechanical energy distorts the lattice of the polymer and induces a potential difference between the upper and lower layer, which allows current to flow. So, how is polymer different?
Conventional PVDF tends to have its own limitations, such as low voltage output. Polymer overcomes these shortcomings and has higher sensitivity, greater output, and enhanced efficiency. To understand how, we need to look into the basic nature of PVDF. In PVDF, there are 3 major phases, namely alpha, beta, and gamma. Alpha is thermally more stable but has 0 net dipole moment. Beta and gamma are the electroactive phases, but with beta showing the strongest piezoelectric properties. Knowing this, we modify to increase the composition of beta phase.
Hence, we introduce to you a novel combination of additives which comprise of reduced graphene oxide, RGO, barium titanate, BT, and lithium chloride, LiCl, to enhance dielectric and conductivity properties of the PVDF. Barium titanium oxide was found to be a good filler in facilitating the beta phase nucleation, while RGO in stabilizing the polar phase in the PVDF. Thanks to the high dipole attraction between BT nanoparticles and PVDF, BT nanoparticles also act as bridge to connect PVDF chains and RGO particles, which further increases the beta phase stability, while lithium chloride is aided to obtain smooth, uniform, and bit-free nanofibers. DMF, which is usually used to dissolve the conventional PVDF, is carcinogenic and not environmentally friendly. Hence, we use triethyl phosphate, TEP, or sarin instead, which are less toxic while being able to perform the same functionality as DMF. Based on our literatures, stretching is found to increase the beta concentration. Thus, we will perform stretching of fabric. With these modifications, a high performance of PVD nanofabric, which is our polymer, is produced.
So, why polymer? Polymer can be applied anywhere as long as there is enough mechanical stress. Polymer could be incorporated into floor tiles, especially in crowded area. For instance, the LRT station or shopping mall. The energy harvested could potentially be used to power up the card reader machine at the entrance of the station.
How about keyboard? With polymer, we can collect energy from your fingertips. When the keyboard is tapped, the mechanical energy could be harvested and used to charge your laptop or other electrical appliances. With the flexibility of polymer, it's also possible to make wearable materials. For example, armband that could charge your phone while you are having exercise. Through polymer, we can advocate about the energy mix through public awareness, especially in energy harvesting technology that should be the alternative for non-renewable energy sources. It will definitely be a step closer to a smart city, as the data collected from polymer could be used for future operational efficiency of the city. The development of this self-sustaining battery could be step for us to create a cleaner energy source and minimize the carbon emission rate. Production of PVDF is found to be sustainable as well. This can be proven by analyzing the life cycle assessment (LCA) of polymer from the synthesis of PVDF's monomer, Vin difluoride, towards the end of life of polymer. Waste hydrogen chloride gas produced during the synthesis of VF2 can be recycled to hydrogen and chlorine gas using CuCl hydrogen production cycle technique. This hydrogen gas, together with the unreacted hydrogen gas, can then be reused back for the synthesis of VF2. During the manufacture of polymer, TEP evaporated during the spinning process will be collected back and reused using solvent recovery system. PVDF is also found to be 100% recyclable, hence, at the end of its life, polymer can either be broken down and used for other purposes or recycled back for the same purpose. Thus, polymer itself can bring environmental impact not only by the reduction of greenhouse gas emission, but greener in everywhere. All these impacts could directly be a better approach towards SDG 7, 11, and 12. Scaling up of PVDF in industry should not be an issue, as the development and production of PVDF has been actively going in electrical and electronics industry. Plus, based on the recent global PVDF market reported by Expert Market Research, PVDF's market is expected to grow at a compound annual growth rate (CAGR) of 4.45% between 2022 and 2027, which shows a healthy trend as it means more investments are getting into PVDF. In year 2021 alone, the global PVDF market has attained a value of nearly USD 900 million and is estimated to reach almost USD 1,200 million by 2027. Key companies such as Daikin Industries from Japan, 3M from Germany, and Arkema from France can be our main investors, as they are the experts when it comes to PVDF.
Furthermore, annual growth rates of the fillers and additive we use into reduced graphene oxide has been used in many industries due to its wide applications and low cost as compared to graphene. Barium titanate is also commercially available due to its ease in adaptation in various electronic industry, even after more than 70 years of its discovery. And the same thing goes to lithium chloride, which has been reported to see a rapid growth in market size due to the increasing use of lithium chloride across the electronic industry and in electric vehicles. Hence, this has proven that developing PVDF is rather mature in industry, showing a low risk and high potential of polymer in market.
With that, Team Tanov would like to bring upon you Polymer, a novel nanofabric that is cleaner, more sustainable, and efficient by using a greener solvent, triethyl phosphate, and reduced graphene oxide, barium titanate, and lithium chloride as additive.
Yes, we could not deny that we have come a long way, but let's look ahead. There's still a long way to go. The world needs a better solution. Hence, we need these 3 R's: rethink, revise, and reshape.
Lastly, we would like to thank ACS-UTP for organizing this challenge. This is Team Tanov, and thank you for listening.
Thank you so much to Team Tanov. Next, I would like to invite the judges to give their comments as well as the Q&A session. A gentle reminder, Q&A session is limited to only 10 minutes. Please welcome.
Okay, let me have the first question. And thank you for your presentation. That's very interesting, because now we have a problem with the energy, right? That you can have the material that can generate the electricity. Okay, so I want to know that how much we can generate the electricity from your materials, how we can find or determine the electricity from your materials.
Hi, thank you, dear Judge. So I would like to answer for this question. So based on the literature and based on what has been reported by the conventional PVDF, all right, okay, we found that 3 by 4 the piece, okay, 3 cm by 4 cm of the PVDF nanofabric, it can generate up to it can power up 100 LED, at least 100 LED, and based on okay. And based on our literature also, okay, and based on the application that we have find in nowadays, minimum it can power up the mechanical motion to charge your phone, okay, by armband. And as we know that there's one company called PaveGen, okay, PaveGen, when we work on it, it will generate electricity. So maximum it can power up to that level. Yeah, generate electricity by people working on it. And anyway, it's very much depends on the parameters like the thickness, the type of electrode, all those things to see the power output. Thank you.
So, how about your material, polymer? Is going to be higher than the traditional one, right?
Yeah, we expect our polymer to produce a higher power output as we try to modify it so that it will increase the beta phase concentration inside the PVDF. So with the increase in the concentration of beta phase and the stability of the electroactive phase, we believe that the polymer has a higher power output. Maybe probably conventional PVDF could power up 100 LEDs, but our polymer could potentially power up maybe 200 or 300, double or triple. Yeah,
Right.
so yes.
Thank you.
Okay. Maybe the next question will comes from me. It's interesting presentation. Yeah. Maybe I would like to continue Dr. Wipo questions. Is there any data on the watt hour of the amount of the electricity that would be generated using your material?
Based on that 1 hour,
What hour? What hour? I mean, what hour?
1 hour. So this
What,
is rated.
What? WATT.
WATT watts.
Yeah,
okay.
What?
Okay. So based on our findings, so if we just based on our finding when human working on it, so this one is actually cited from the paper which is published in 2022 March, which is this year. Okay, so it can power up to 2 point. Sorry, maybe give me a second. We did have a data on it. So yeah, okay, if based on human walking, it can exhibit output voltage, current, and power of 210 volts, 45 milliampere, 45 microampere, and 2.1 watts based on human walking. Yeah.
Okay, so basically, in your wildest, maybe your wildest imagination, is it possible? Yeah, because in the earlier, it is you are compared with the coal, yeah, which has used it extensively in our industries. Is it possible to use the materials for become the source of energy of a very big equipment, for example, a boiler, yeah, as you mentioned, because it's already applied in the maybe in the keyboard, yeah, or those little small electric appliances, yeah. So is it possible to be able to apply it into quite bigger equipment, such as, for example, in the boiler in the industries, using your material?
Yeah, let's answer this question. And thank you, Doctor, for that question. Yes, it is possible that polymer could potentially be one of the replacement of the energy sources. And yes, for like basic applications, for example, to power up boiler or even to power up a lamp or anything, it is possible. Yeah, to answer this, like just now, Doctor, you mentioned that coal has been used widely for electrical appliances. But then let's take a step back and look at the big picture. Coal is not sustainable, and it is widely known as non-renewable energy sources. And as we look back into our history, when solar panels was firstly proposed, those electrical energy might not be that high, and it might be quite expensive by that time. But then as we look now, solar cells has been improved, and the cost is actually quite reasonable. So we believe that polymer, even though now it might seem to be quite expensive, and it is like a bit, the power output isn't like very, it is like to power up only few hundreds LED. But in the future, who knows that this could be one of the things that we could use to replace fossil fuels, to replace solar panels, to replace wind energy, or to help with incorporated in those things so that we can produce more energy. It is a cleaner alternative energy sources. Yes, and that concludes my answer.
Okay, thank you.
Thank you, Dr. Anissa, as well as Associate Professor Wipo. We have a minute and 30 seconds left. Maybe we can proceed with one last question for this team from any of the judges, if it is possible. Dr. Steven or Ms. Cho Mi-Ling, do you have questions for Team Tanoff?
Hello. Yeah. Good morning. Team Tanoff. Yeah. Very interesting applications of these new polymer materials. So again, I'm actually interested to know more about the recyclability of these materials, because according to one of the life cycle assessment, you mentioned that it's 100% recoverable, right? But as far as I know, usually for this piezoelectric material, usually it will be applied in different appliances and used also in combination with other materials as well. So, do you have any idea how easy is it to recover all these polymer materials from the appliances? Yeah.
Thank you for your question. So I would like to answer for that. So as we know that PVDF is actually degradable, and this is actually has been reported, and there's a statistic on it because based on the Arkema, the company report, PVDF is actually can be processed and reused up to 5 times. So that's a quite that gives an positive environmental impact, yeah, in the sense of how we use the material. And from the side of the solvent we use, okay, and the material we use, the additive we use is actually lead-free, yeah, if compared to the conventional one, because the conventional one, majority of them, they use ceramic, which is toxic. So to replace that, we use other additives such as BT, which is free of lead. And from the solvent, of course, we have mentioned before, the solvent we use styrene, which is biorenewable, and TEP, which is less carcinogenic compared to the DMF, which is the conventional one. Yeah, so this is our main tip. Thank you.
Okay, thanks for explanations. Hopefully these polymer materials can be mass produced soon to create a better sustainable world for us. Thanks. Thank you.
Thank you. Thank you, dear judges.
Thank you, dear judges.
Thank you so much to all the judges. So far, we have witnessed 3 groups present their remarkable and amazing concept on the fabric and polymers. I think everyone here already so interested and excited to see the next presentation, right? So without further ado, let's welcome our 4th group, Team UKM representative from University Kebangsaan Malaysia, UKM, to deliver their presentation. Please welcome.
1.1 billion people worldwide suffer the lack of access to clean water source. And that is where I, Hariwalagan, and my partner, Raul Lengam, comes into the play. We believe the portability of water filtration is the key to water security and efficiency. Carbon quantum dot are a new class of carbon nanomaterial which is added to a specific type of thermoplastic membrane which is called polysulfide, or we can say PSF. With this modification, this membrane we call CQD PSF membrane has a very good properties in both antibacterial and improvement of water flux, and this improvement makes this as a very suitable material for a water filtration improvement. Let's look at the problem statement. Well, as we can see, there is two important issues, water security issue and biomass sustainability. And when we look at the stats, that's proving that water security is something that we have to now right away, and biomass is an important issue that we have to handle to ensure a better future. However, let's look at this graph that visualizes that Egypt is approaching absolute water crisis. Total population is ever been increasing, however total renewable water resources per capita is decreasing, and this is proving that's a serious issue that we have to handle. We do believe that every problem that we already stated has its solution. However, the efficiency of the solution is the lacking problem, and this is where our idea comes into the play. We believe PSF membrane coated with CQD carbon quantum dot has shown generational leap in the water filtration technology, and this is why. PSF membrane has a lot going for it. However, there are three important disadvantages. Number one, relatively high volume properties. It means the debris flowing through the filter will get accumulated over time quite frequently, and this means the service or the exchanging period of the filter that has PSF membrane is very short. And next, we can see the lack of antibacterial properties. This means you require other type of membrane as well in the filtration system to ensure that bacteria is inhibited. And last but not least, relatively low water flux. And this is bad because once the water flux or the flow is very low, it means you require the motor or the pressure motor to work even more harder. This means the energy efficiency of this kind of PSF membrane in the water filtration is very bad. Let's look at the solution that we propose, CQD modified PSF. So first we have to understand what is CQD, carbon quantum dot. It is a material with so many amazing properties, but there are four properties that we're going to look right now. Low toxicity, low cost, antibacterial, and antifouling, and these are the four important properties. Through the modified advantage together. Number one, when we enhance antibacterial activity, it means the surface gets smoother and CQD has negative charge. That means bacteria can't adhere to the surface and bacteria will be repulsed because of the CQD negative charge. And then when we look at antifouling properties, CQD layer that able to increase the antifouling properties indirectly increases the longevity of the filter because no debris gets stuck. It means with the period of changing the filter that has CQD modified PSF is so much more higher with just PSF. And then we also can see the extra smoothness and also the increased hydrophilicity of CQD will ensure that the water flux value is so much more higher. It means it works more efficiency as a water filtration.
And here's the water flux test that not only prove that adding CQD makes the PSF to perform better, but make it perform better comparing to other types of water filter membranes. Atomic force microscopy explains the increased smoothness after adding CQD towards PSF membrane, and diffusion distance prove that there is higher antibacterial activity after the adding of CQD, which improves this as a water filter.
there's two parts. The preparation of CQD, which is using the hydrofluoric treatment and then filtered with 0.22 micron to get the CQD. And then we also use the normal PSF substrate preparation to get the PSF membrane base. And together they are merged with a sophisticated process, and at the end of the day, they can be added to use as potable water filters.
All right, thank you so much, Hari, for that. But before talking more about our product, we want to explain more about the impacts that it has to Malaysia. As you can see here, our impacts, which are environmental, economical, and social, are actually aligned with the UN's Sustainable Development Goals, which are climate action, decent work and economical growth, clean water, and sanitation. So first of all, for the environmental impact, we have to note that our SQD membrane filtration are actually made from organic compounds. It can be made from any organic compound. So what organic compound that we are using? We're actually using biomass. And also to note that annually, a minimum of 168 million tons of biomass waste is generated in Malaysia. And as for the CO2 emissions, it can also be reduced as we use the biomass because less waste is generated in the landfills. And the key takeaway is using sustainable materials from any biomass, we get to reduce the biomass in Malaysia, and also our product is biodegradable and we get to lower CO2 emissions, therefore less waste in the landfills. Next, we'll be talking about the economical impact. So the water purifier market is estimated to be 393 million USD and is estimated and anticipated to grow another 10.24%. And it was forecasted that it will generate a revenue of 722 million USD. So this shows that we have a large market and also a large demand for cleaner water. So the key takeaways right now is the birth of a new niche market in Malaysia, new exports from Malaysia, we get to contribute to the GDP growth in Malaysia, and also we get to generate more revenues for farmers because they will be able to sell their biomass to us and also reducing the carbon footprint. Next, we'll be talking about the social impact. Over 4 billion, almost 2/3 of the world's population, experience severe water scarcity for at least a month each year. And only 71% of the people in Kelantan have access to clean water. And 1 in 3 people globally do not have access to safe drinking water. And what we aim to do actually, we aim to provide water security to everyone, prevent waterborne illnesses, and also raise sanitation standards, potentially also helping victims in Malaysia who are facing floods or in rural areas that can't obtain clean source of water. As you can see over here by the framework created by the Kerajaan, we are actually using advanced materials to tackle water security. Right now, we'll be looking into our target audience. So we are aiming for industrial water treatment customers, process separation customers. This is because they usually leverage on demand water reuse and high production capability. They usually look for new sustainable filtration breakthroughs and they are concerned about water security. Because this is a niche market, there's a high growth potential in the membrane market because of the demand of advanced treatment solutions for reusing and recycling water. And as for the price advantage, we have a significant price advantage over other companies as the way we manufacture our filters have a significant lower cost than other conventional method, where one piece of membrane will cost only 1 ringgit and 87 cents to make. And lastly, more sustainable production methods. We can utilize any biomass in Malaysia to be turned into carbon quantum dot for us to produce our filters. So these are actually some of the advantages that we have against the conventional filters. Next, we'll be talking about our take on the live straw. On the left, you can see the conventional live straw, where it can be bought for 30 ringgit per piece, and our concept, which uses a membrane filter which is cheaper and also more sustainable. And also we like to include a modular design so we can actually swap our filters. And also the price will be significantly lower because we're using, yet again, I would like to say biomass, which are abundant. And also what reduces the cost is because we only use one type of machine to create our membrane filter, which is the autoclave machine. So a lot more cost will be reduced. So right now, I'll share to you how we plan to scale this small project into something big. Well, there are 4 phases. The first phase is licensing and also patenting. So we plan to work B2B with other big commercial companies or business to business. As you can see to your right, we actually have a plan where we aim to get licensing fees and also royalties from these companies. And we have a goal that we want to reach, which is a 5-year ROI of 1 million ringgit. And how do we get this? Of course, by the licensing fees and also the royalties. For the second phase, we plan to collaborate with the government to create a Malaysian brand filtration straw. For the third phase, we plan to supply our filtration straws to rural areas and flood hotspots in Malaysia. And the last step, we actually plan to export all of these straws, which is the Malaysian brand straws, to Southeast Asia so that we can generate more income and also it could help people inside Malaysia and also out of Malaysia. Thank you.
Such a wonderful presentation. Thank you so much, Team UKM from University Kebangsaan Malaysia, UKM, for your sharing related to the membrane filter. I will open the floor to judges for any comments and questions. It's generally a reminder, Q&A session is limited to only 10 minutes. Thank you.
Okay, maybe I start with the first question. Okay, I think everybody here know nowadays in the market, actually we have a lot of brand. Okay, we can buy a water filter from like those famous brand, Cuckoo, SK, Conway. So in your propose, so have you ever do a comparison? What's the difference between yours and those branded type? And do you do a market technology survey? Because in your proposal, you mentioned that your membrane is much better than the others.
Okay, I can answer that. Okay, yes, we actually did do a comparison with other commercial filtration brands such as Cuckoo. The technology used is some of them use UV filtration. Some of them use nano positive filters, so and so forth. But right now, the reason why we're not comparing it to commercial filtration brands is because right now we're focusing on our product, which is the live straw. So this is more for household areas. This type of filters like Cuckoo, so on and so forth. But we did do our research, and based on how different it is, right now what we will say our niche, not really niche, but what is our plus in this is actually the how we produce it and how much it costs to produce it. As I like to say, it costs under 2 ringgit to produce, so means this is a cost-effective way. So I would say we have an upper hand from all of these competitors because of how efficient and how cost-effective it is for us to actually manufacture and supply it. So this is what I would say would be a plus or our upper hand. Sorry, can you hear me? Oh, okay.
Yeah, that's all from my side, the question.
Okay, let me have one question for your team. I think you are doing about the material that coat the membrane, right? And you apply for the house store. It look like that in the cylinder, right? So is it possible that we can do in other shapes, any shape, like the plate or other shapes we can use for your materials? So you can. So is that possible?
May I answer this? All right. Thank you so much for that interesting question. That is a really good question. If it's able to do in multiple different shapes, we do believe they can come in different shapes, but this shape has been proven to be the most efficient shape because it can be used as a live straw. So basically what we're trying to bring up to the market is that in Malaysia, especially during seasonal time like flood time, we believe that there are certain regions that are going to go through problem of unclean water. It's not that we don't have water supply, we have unclean water supply. So rural area from Sabah or Sarawak, which is a part of Malaysia that goes through even more difficulty of getting clean water source. And in this kind of scenario, we believe like live straw, especially when there's a flood system and then the water source is totally contaminated, we believe like the live straw shape, the cylindrical shape, is the most suitable shape because you can just drink up the collected water as if you're using a straw normally. So if you say that you want to bring up in different shape, that is possible, but I think this shape is mostly preferred in the target audience that we are looking at. Thank you. I hope I answered the question.
Thank you.
One more question is if you compare with the commercial brand, they always can be reused, right? Reservice, rewash. So in your membrane, do you still have this feature? Because I see from your picture is same thing in the cylinder shape as well, like a cartridge, right? So this cartridge is one time off or it can be used for many times?
All right, I'll answer this.
Okay, all right.
All right, so basically, it's based on one-time use. So we are expected the longevity or the lifeline is expected to be 6 months. So so it has to be constantly changed, like how different it is from like cuckoo and all. So cuckoo only you just have to open and clean it, so and so forth. But for ours, you usually just have to, because of how cost effective it is, we can just swap a new one. So it will in a way save time too. Yeah.
So the ownership, will it be higher?
Sorry?
The ownership, will it be higher? Because just now, if I remember correctly, you are talking about 2 ringgit.
Yeah, that is actually our cost price. Below 2 ringgit is our cost price right now. But for the ownership, as in like from the consumer side, owning it and buying, changing up, swapping up the filters, it will be definitely higher than 2 ringgit. It will definitely be higher than 2 ringgit. Because we have to package it, so on and so forth. But it will be significantly lower than usually asking it to be serviced by the people, by the workers or the maintenance people from the site that you are, from the commercial side lah, of the filtration company. So theoretically also, we can say that you don't need to have someone to service it. You can do it yourself, where you can actually put it in yourself too. Sorry, you can put it like apply and like swap out the filters yourself too. So you don't need any experts. So what you just need is just a filter lah. But right now we don't really work on that because we're focusing on the straw itself. Maybe that is something that we can actually look to in the future. Thank you.
Okay, thank you also. Yeah.
Maybe we can have one more questions. Is there any?
Okay. Maybe I would like to ask one simple questions. Thank you for the interesting presentation. Well, my question is it the membrane, is it going to be applied as one solution for all for the water, or you are going to combine with the other process, as you mentioned? Maybe the membrane is capable to remove what, and then maybe you are going to add an additional treatment to be able to get a clean water.
Right. Thank you so much for that question. We do believe that what we're trying to say is that our idea is suitable for a life choice. It's a suitable idea to make a very cheap solution for those people who have water security issue. So those people who are having difficulty of not clean drinking water, they can use this kind of solution, which is very, very cheap, which is in comparative to any other market before, is drastically cheaper. And not only is cheaper, it works even better because it has a very strong antibacterial effect compared to other things because of addition of carbon quantum dot. So that is what we're bringing towards the table. We're bringing towards the table a technology, a generational leap of technology where the able to improve antibacterial properties, but at the same time, it's going to be so much more cheaper thanks to the addition or the usage of a more sustainable material as the source. I hope I answered the question. Thank you.
Thank you for your answer.
Thank you so much to all the judges for the questions and the comments. We are quite behind of time, so let us move on to next presenter. And thank you so much to Team UKM for your presentation just now. Next, let us welcome Polymer Preachers from University Malaya UM. You may take the floor.
What happens if we buy food with plastic packaging today? And maybe because we're too tired to eat out, we order lunch through food deliveries tomorrow, and the next day, and the next. Don't believe us? We asked people how many times they ordered food with plastic packaging. Take a look.
About 10 times per month.
Almost every day.
2 to 3 times a week.
5 to 6 times a month.
It's cool for a good hour, and you finally get a happy stomach. But let's be honest. In the long run, it's just not great for our planet. Out of the millions of tons of solid waste produced, a 2019 survey showed that 63% of it is derived from containers and packaging around the world. Although biodegradable plastic is a better alternative, our project suggests the integration of banana composites to create a better lifestyle for the consumers and the environment. Let us introduce to you effective biodegradable polymers for daily use to pack your problems away. And our project aim? To enhance biodegradable polymers for food production.
Main objectives are 1. To reduce plastic waste by recycling plastic and integrating coconut shell into food production process. 2. To enhance the barrier properties and mechanical strength of biodegradable food packaging by incorporating nanoparticles into biocomposites of food production.
That's right. We plan to create biodegradable food packaging, but better.
Now, what is all this talk about bio-nanocomposites? In fact, what are they? Bio-nanocomposites are hybrid nanostructured materials based on natural polymers with enhanced functional and structural properties. After further research, we found that coconut shell bio-nanocomposites with polypropylene plastic packaging as a matrix act as the best material as it is more readily available. Before we dive into the project activity or process of making the packaging, we have to first prepare the materials. We will need coconut shells and recycled polypropylene, or better known as waste plastic packaging dissolved in saline. We will also need an initiator and a copy agent like benzoyl peroxide. For the reaction solvent, we will use methanol. And lastly, as a modifier, anhydride malate.
Once all the materials are prepared, we would have to mix all of them together at 60 degrees Celsius for 60 minutes. This will initiate the bridging interaction in the bio-nanocomposite. Here, a few combinations were tested in order to find the perfect amount of matrix to nanoparticle filler ratio. The optimum performance of the bio-nanocomposite was obtained at 30 to 70 weight percentage plastic waste to coconut shell ratio. Then, to put it all together, the sample mixture is transferred into the extrusion, heated at 180 degrees Celsius with 30 RPM of the motor speed. Finally, a compression molding machine made of steel is used where it was equipped with an electric heater, hydraulic press, as well as a thermal controller of up to 350 degrees Celsius. The mixture is then pressed with 3 tons of load for 1 hour at 175 degrees Celsius to obtain a bio-nanocomposite sample.
Now, you may be wondering, why make this change? Truthfully, we can go on and on about the great project outcomes this initiative will bring, but to name a few, the performance of biocomposites will improve significantly with a lower percentage matrix and filler nanoparticles. Tired of weak plastic bags dripping or having holes? Well, with this 30 to 70 weight percentage ratio along with an increased milling time, reinforces not only the flexural strength and modulus, but also the compressive strength. In other words, you won't have to deal with it anymore.
Other than that, the bio-nanocomposites display improved barrier properties.
This is due to the dispersal of nano-sized fillers into polymer matrices that create a tortuous path for gas diffusion rather than a straight line. This alters the permeability of the polymeric material to gases, producing larger effective film thicknesses, all while using smaller amounts of polymer. Ultimately, our goal is not only to produce strong, flexible packaging, but also ones that protect the food and keep them fresh for a longer period. The shelf life of food will improve tremendously as the dispersion of oxygen and water vapor allows the food product to undergo cellular respiration.
There are numerous positive impacts this method could bring, including reduced carbon footprint. Since the packaging is eco-friendly, it reduces the amount of wasted materials and consumption resources. Not only that, the recycled materials and amounts of polymer used for production is cheaper, thus minimizing cost. The packaging can also be disposed of conveniently, no matter if the consumer prefers to compost or throw in the bin. In terms of social impact, it can create future jobs. For example, drivers for transporting the materials, technicians, machine operators, engineers, and scientists.
However, there are negative impacts to this project as well. This technology reinforces a single-use mindset. Consumers may turn to biodegradable plastics as the best solution for environmental issues, passing up more environmentally friendly practices such as low-waste living, recycling, and prioritizing organic materials. Lastly, it may not break down completely. Although the packaging can be naturally degraded by bacteria, there is a risk that the coconut crops are sprayed with pesticides and can easily be transferred in the end product.
Our innovation strategy to scale up is an incredibly important element in taking our project to greater heights, or even internationally. We decided to focus on 5 C's, which are capability to relate and partner, capability to resource and act, capability to adapt and navigate challenges, capability to make scaling contribute to sustainable development, and capability to anchor the innovation in institutions for continued scaling. To relate and partner, we have explored companies that share the same vision, like BASF, Total Energies Corbion, Eastman, and Futamura. Apart from owning the best bioplastic company titles, these organizations can help with the product marketing and attract many potential sponsors.
To resource and act, we understand the need to earn funding for materials and the machines to create our effective biodegradable packaging. This will create opportunities with the coconut industry like Kara's eco plants in providing the unwanted shells.
Next is to adapt and navigate challenges to ensure that our product serves its purpose well. By collaborating with partners, we could experiment to develop strong processes and systems.
Moving on, the scaling must be able to contribute to sustainable development. This can be done by constantly evaluating the most eco-friendly ways to fully utilize the materials and at the same time, reduce the least amount of harmful chemicals throughout the production process.
Finally, anchor the innovation in institutions for continued scaling. Our effective biodegradable packaging can work hand in hand with universities which aim to implement a green campus like University of Malaya. So now, it all comes down to the big question. If you were given an alternative that might change the world for the better, would you use it?
Yes.
Yes. Yes, definitely.
Yes!
Join us in packing our problems away by using this new and improved biodegradable food packaging for the betterment of our planet. Thank you.
Thank you to Team Polymer Preachers for the very interesting sharing on effective biodegradable polymers. Now we will open the floor to the judges for 10 minutes question and answer session. Please welcome.
Thank you to the great presentations by Polymer Preachers. I'm Dr. Stevens. So maybe I'll start with the Q&A first. Okay, so there's a very interesting concept of combining coconuts, the shell, and also with the recycled plastics. Again, just wondering why particularly these combinations, like why you use coconut shell and also this polypropylene, right? If I'm mistaken, yeah. So any particular advantage for these materials?
Okay. Hi,
Thank you so much, Doctor, for the question. So yes, we have studied other biodegradable plastics that are also available in the market. And one that we've come across is the cornstarch-based biodegradable film, which we think is a brilliant idea. However, there are 3 drawbacks that we've seen, including its rigidity, brittleness, and also high hygroscopic properties, meaning it absorbs a lot of moisture in the air. So what we've decided to do is incorporate coconut shells to overcome these problems. And for now, I'll pass on to my partner who will explain more about the coconut properties.
All right. So again, thank you for that question. You see, in our aim, we choose to do a more environmentally friendly approach. That is by using waste materials instead of buying newly bought ones. And according to an article by Textile Today, there are approximately about 50 billion coconuts grown worldwide, and about 85% of the husks or the shells are discarded as trash. So that's why, with the chemical composition of coconuts that make it able to bond better with the recycled propylene, it's actually the perfect material to be used as our filler nanoparticles for our biodegradable plastics.
Okay, thanks for answer. But just curious, like, can we replace the coconut shell with other types of biomass material as well, such as from palm oil industries? Is it possible?
As we have researched, we did manage to find a few other types of materials like chitosan. So chitosan is actually derived from the shells of crustaceans, which has been dissolved in alkaline substances such as sodium hydroxide. But we believe that coconut shells is more readily available to be used, and it's easier to be to get the coconut shell essentially. Yeah.
Okay, thanks for the explanation. Maybe one last question, because I saw from your slides about the biodegradability of these biofilm plastics that you have formed. So, and you say it's not completely biodegradable, right? So, but since now we're talking about biodegradable one, if it's not completely biodegradable, so it might still create issues. So can you further explain on this?
All right, thank you, Doctor, for the question. So, of course, our main problem that we want to tackle here is to reduce the problem of marine litter that is worsening over the years. And yes, while I do agree to the fact that it's not completely biodegradable, we're still in the process of trying to develop better systems and processes. Of course, there are still drawbacks to our project. However, with the biodegradability, we do hope that we can find ways to maybe get these coconut shells without it being sprayed by pesticides in the first place, which is the problem to why we have a slight disadvantage there in terms of biodegradability. Thank you so much.
Yeah, thank you. Wish you luck to find a good replacement for these materials. Okay, thank you. That's all from my side.
Okay, let me have questions. Okay. Thank you for your presentation. First, I want to know about the you said about the permeability, right? That if we mix the coconut with the polypropylenes, will be the increasing the permeability. So you have any ideas what kind of gas that it can this material can protect the gas? You have any data like it's going to be good for oxygens or CO2 or nitrogen, something like that? Do you know?
I think I can answer that question. So thank you, Prof, for that question. So basically, in terms of permeability, we mostly explain it in terms of barrier properties. So barrier properties refer to the ability of the packaging to resist the absorption of moisture and oxygen. So with the barrier properties, we create like a tortuous pathway, which actually disperses the oxygen and water vapor better, and we're able to control the respiration. As we mentioned in our video about cellular respiration being important for shelf life of food, cellular respiration is important to maintain the shelf life of food, but with the barrier properties that we have increased, we are able to control that respiration time to ensure the improvement of the shelf life of food.
Okay. So how about mechanical properties? It will be increased? Mhm.
Yes, so mechanical properties that we focused on is mainly the flexural strength and modulus, as well as the compressive strength. So as I understand, the flexural modulus is actually the ability for the packaging or the material to resist bending, and strength is the behavior of the structure in direct bending. So either way, they are interrelatable, and they're both important in order to make our biodegradable plastic bags, but both have increased values, which are equally important for the durability and flexibility of our bags.
All right, thank you.
So maybe another question from my side. I'm not sure whether you're aware about the microplastic issue in the environment. So when you talk about this biodegradable product, have you do any relevant research for this?
Hi, thank you, Miss. So I would like to answer that question. Yes, we are aware about the microplastic situation all over the world. And so what we've decided to do is to actually incorporate recycled polypropylene into our product to actually combat this problem. And at the same time, that's why we're working on it being also biodegradable, meaning that it could be decomposed, also degradable by just using oxygen. Again, as I've mentioned earlier, there are still a few features that we would like to work on, mainly it not being 100% biodegradable, because we can't say that yet, but we are aware about the microplastic situation, and we do take that into account when we are planning this project.
Okay, I see in the future, I believe nowadays when you go to restaurant, you can see there is a food grade straw, right? Then they say it's turtle friendly, so turtle can eat it without any issue. So any plan for your project to working toward this direction?
Yes.
You think it's possible?
Yes, I think it's possible. The straws that we usually see used in restaurants are actually made out of mainly, right? So for our one, we decided to make it more marine friendly in terms of it being able to biodegrade also in water. So that way, we don't have to worry so much about it being lasting around more than 450 years, like the normal traditional plastic, right? So with our project and based on our research on average biodegradable composting time for biodegradable plastics, it would take around 3 to 6 months. So our aim is to make sure by the end of that 6 months, we would not see any of those plastics anymore. Thank you.
Okay, thank you.
Thank you for all the questions from all of the judges, and thank you as well to Polymer Preachers on your interesting and amazing presentation. Hafiz, what do we have next?
Next, I would just like to talk about, we have a break, but before that, I would like to say, wow, we have seen around 5 presentations up until now, and I just wanted to say that all presenters present their topic very well, were related to energy generation, such as by a solar cell, and also filtration membrane, and also related to our huge problem in the world, which is pollution caused by plastic to our environment. Thank you very much to all the judges for the questions and comment given. Now, let us have our tea break before continuing to the next presentation. Enjoy the short break and see you later at 11:20 a.m. Thank you very much.
Applied chemistry is in our everyday lives. We see chemistry in almost everything. For example, the air we breathe, the food we eat, and even the fuel that powers up our cars. Chemistry is important because we see it in our everyday lives, and everything we observe is due to chemical reactions. My best UTP experience, I developed a catalyst to convert carbon dioxide into methane. And aside from my FYP project, I also managed to lead student organizations such as the Society of Petroleum Engineers student chapter, where I was elected the Deputy Vice President.
I did my 7 months of internship at Japan. The experience is very amazing and very great. I'm doing the research is regarding about the deep utility solvents using as a catalyst or as a core solvents as well to enhancing the biodiesel.
Chemistry is an important part in any future industry. Thanks to UTP's strong industrial linkages, as well as the wide range of expertise, I can apply what I've learned in the industry.
Backed by strong ties with Petronas, the parent company of UTP, the graduates from this program is able to tap onto that opportunity and enter into the oil and gas industry in Malaysia. The content of the program allows some level of versatility for the graduates to explore beyond the oil and gas industry in Malaysia. So it pushes the boundary to explore all other job options available in the country and also regionally and so internationally. So that makes UTP graduates high-value graduates.
As you know, in our applied chemistry course, for the first 3 years, the student will be doing fundamental chemistry. They also will be doing some computational chemistry. So after the 3 years, they will do a specialization. They can do research projects. So in this research project, they can do either in environmental, they can do in catalysis, they can come up with new materials that can reduce pollution. After they have done this research, we believe this will equip them to go into the job market. In Malaysia, a lot of companies are looking into chemistry who has knowledge in this area. So we believe in UTP, we will prepare the students for this job market that is not only today, but will be useful in future.
UTP Applied Chemistry Program receives prestigious accreditation from the Royal Society of Chemistry, or RSC, positioning the program to be internationally recognized. This provides assurance to employer and students in a competitive global job market. The RSC recognition also gives opportunity to students and academic staff. The Mobility in Exchange program among the RSC accredited institutions worldwide. The Applied Chemistry program in UTP also offered 3 specializations, namely petrochemistry, sustainable chemistry, and nanotechnology, to cater for the Industrial 4.0.
The youth is important in Malaysia, and it's very important for us to ensure that they can participate in Malaysian well-being. So besides securing a job, we want to also get the students involved in the nation's issues, especially in environment, in pollution, in coming up with alternative energy. In UTP, we believe our course is preparing the students for these areas. When the students make a discovery in the lab, especially in their final year research project, we ourselves, as a lecturer for past 21 years, we feel the honor to see the light in their eyes when they find a discovery. So, and many times these students have made useful discovery, which we are using it for our research project in later years. Coming to UTP is a good step for our youth to take up especially the applied chemistry course which we are offering here. Join us. Together we can dream up new possibilities.
To those of you who have come in search of answers, seeking inspiration and looking to achieve your aspiration, this is the place where you will learn to find the answers, where you will be motivated to discover your inspiration, where you will be propelled to realize your aspirations. With today's global challenges, the role of the engineer, the scientist, and the technologist is transformed from being the technical innovator into being the agent of global change. Our world-class resources and faculties, our cutting-edge facilities, our global partnerships with leading universities, our strong network with industry for internships and job placements. Our worldwide research collaboration. These are the inspirations and the opportunities at UTP. Here, we nurture the analytical skills and intellectual capabilities of all who walk the UTP path. Here we culture the ethics and the attitudes that will shine in the real world. Here we expose ourselves to what it truly means to be human, to be a valuable part of society, to be the empowered people, the game changers, who will light up the path towards a better world and change lives for the better. At UTP, the torch is firmly in your hands. So hold it up high and let us together light it and let it burn bright. Join us to seek inspiration and achieve your aspiration towards global prominence.
How you doing?
Hi, great.
What's your name?
Kang.
Kang.
Nice to meet you.
Where about you? From Malaysia, right?
Yeah, I'm from Malaysia.
Excellent. How long have you been in?
About 4 months. I'm working on composite manufacturing, so I've been given a chance to work in the composite laminating room. The composite manufacturing department would like to implement a new technology into the composite laminating, whereby they use the laser positioning technology to reduce the time needed to manufacture this retard wishbone.
First time you working with CAD? Or
No, I learned some bits, pieces in university.
What can you take home with you?
Yeah, definitely is the teamwork. Yeah, and they help me to develop my skills bit by bit.
Excellent. Well, I hope your experience here has been great.
Yeah, it's great.
Hope the next 2 months you learn a huge amount so you can take back with you.
Yeah.
And you'll always be welcome back.
Yeah.
All right, buddy.
Nice to meet
you. And you. How you doing?
Hi, nice to meet you. My name is Praveen.
Praveen, nice to meet you.
Yeah.
How's your stay been?
It's been great so far.
You've been here for 4 months, right?
Yeah, since January.
Excellent. What have you been working on?
So I've been working in aero inspection, mostly because my supervisor Michael full of that. So what we do is inspect all the parts before it goes to the model shop. I'm using like scanning equipment to scan the parts, also manual checks on the car.
Hi everyone, welcome back. We are going to continue our agenda for today with the rest of the presentation. I hope the contestants are ready as well as the judges because we just finished our 10 minutes break. Let's welcome Impactor from University Malaya, UM. The floor is yours. Please welcome.
In ancient times, the textile and material of fabrics have portrayed human civilizations and technology. However, people nowadays have recognized clothing as a fashion. Humans use natural such as silk to make clothes. The type of fabric can be classified into two main categories, which are fiber and polyester. Cotton is one of the examples of natural fibers, while microfiber, rayon, nylon are the examples of polyester. Nylon is one of the common synthetic fibers being used in the textile industry, as it has its specific characteristic where other fabrics could not meet. In this modernization era, people are being exposed to a wide range of news, information, and data. People know the right clothes for the right activity, and they will choose to wear high-quality clothing. There exists sportwear made from different fabrics on the market for them to choose. Different fabrics have different characteristics. Good day, everyone. We are from Group Impactor. My name is Fong Sumei, and my partner is Tan Jasik. In this video, we are going to talk about nylon spandex for sportwear. These are the contents that we are going to focus on in our video, which include problem statement, project M, project activity, impact project, project outcome, ability for industrial to scale up, and conclusion. Problem statement. The sportwear material with nylon material only does not possess elasticity properties. People seek high quality and comfortable clothes. Humans wear different clothing on different occasions. While going for sports such as swimming or jogging, people choose to wear sportwear rather than casual clothes, as sportwear could improve their performance and bring extra comfort to them. Nylon is one of the common synthetic fibers being used in the textile industry with its stain-resistant or mold repellent properties. The most popular nylon being used is nylon 66, which is the strongest of the nylons. The sportwear material with nylon material only is not suitable for sportwear material, although it possesses long-lasting properties. This is because its lack of elasticity is not suitable for some of the sport activities, for example, swimming or yoga. The sportwear with nylon material only will restrict the wearer movement. Project M. This project aims to improve the properties of nylon fabric to make it elastic so that it is suitable for sportwear. A good and high-quality sportwear can help to protect muscles from inflammation and reduce the risk injuries. Nylon material which lack of elasticity needs to be improved so that the sportwear made with nylon can be more comfortable to wear and easier for the movement. Project activity. Nylon is a polymer made up of a group of monomers. Diacids and diamines are the reactants used to produce nylon 66. ATP acid is the diacid that can be used, while hexamethylene diamine is the diamine that can be used for the manufacturing of nylon. This reaction is neutralization reaction. There are three important steps to manufacture nylon, which includes polycondensation reaction, melt spinning, and drawing. The nylon salt form is purified and heated up to 285 degrees Celsius to produce nylon 66. The byproduct produced, such as water, needs to be removed at the end of reaction. The innovation that can be made in order to improve the nylon is adding spandex to the nylon. The product form is nylon spandex, which is the combination of nylon and spandex. Spandex is a synthetic fiber which is light and heat resistant. Its high breathability and good elasticity make it suitable for sportwear fabric material. Spandex are produced by going through 4 processes which include melt extrusion, reaction spinning, solution dry spinning, and solution wet spinning. 2 types of polymers reacted to produce stretchable spandex fibers. One is microglycol, while the other is a diisocyanate.
Project outcome. Nylon spandex is able to return to its original shape after use, and it is a very comfortable fabric. It is soft, lightweight, and resistant to body oils and perspirates. It is also resistant to abrasion and does not easily wear away from friction. Besides, nylon spandex is a static-free fabric. Hence, nylon spandex is suitable for sportswear materials. Impact project. First, manufacturing of nylon will produce nitrous oxide, which is a greenhouse gas that is 310 times potent than carbon dioxide. It leads to air pollution, which becomes a threat to humans. Next, the manufacturing of nylon requires a large amount of water for the cooling process, and the water used for cooling will be a contaminant that causes water pollution. Moreover, nylon manufacturing consumes extremely large amount of energy, which leads to degradation of the environment and global warming. Manufacturing of spandex produces toxic, which is carcinogenic and could cause mutation to humans as it is made from polyurethane. Ability for industrial to scale up. The glassrod procedure's preliminary design includes an extruder, a pump, 2 heat exchangers, 2 reactors, a process vessel, and an air cooler. To increase polymerization and nylon 6 production, the chosen technique employs a batch reactor in series with a CSTR. The grassroots facilities is anticipated to generate $123.3 million in annual revenue. The design has an estimated $4.03 million in capital expenditures overall, including fees, contingencies, and a glassrod component. The annual cost of manufacturing is expected to be $89.3 million, including the cost of raw materials. The procedures were also set up for cases with a 67% turn-down rate. The reactants used to produce the spandex are microglycol and diisocyanate. The raw material, microglycol, which costs around $164, while for isocyanate, the estimated raw material cost is $2,750. The selling of raw material for the reactants in bulk allow the factory to produce the spandex in big amounts. Nylon spandex is able to be found on the market. Different proportions of spandex or nylon in the fabric gives different prices and values for the fabrics. The nylon spandex sold on the market not only having different proportions, but also with various designs and colors. The manufacturer has introduced nylon spandex to the market together with its functions and its benefits. For example, nylon spandex for yoga legging, nylon lycra for yoga mats, and also nylon spandex fabric for sportswear. It is known that synthetic fiber is cheap, lightweight, and could be produced efficiently. Hence, nylon spandex, the synthetic fiber which is lightweight, is conveniently to be produced. The lightweight properties of the nylon spandex also helps to reduce the transportation fees. Conclusion. Nylon spandex possesses the elastic properties which is suitable for sportswear. The properties of nylon spandex combine the nylon properties and spandex properties. It is stretchable and long-lasting. Although it sticks to the skin, its high breathability properties still brings comfort to the wearer. The waste management for the production of nylon spandex needs to be improved in order to reduce pollution to the environment.
Thank you to Team Impactor from University Malaya UM. What an insightful sharing. I enjoyed your whole video. And now let's open the floor to the judges for any questions and remarks. A gentle reminder for the participants to double check your microphone as well as your webcam, and the Q&A session is limited to only 10 minutes. Please welcome.
Okay.
Dr. Anissa, actually, I cannot hear you on our side.
Okay. Is it?
Okay, yes,
Okay.
now we can hear you.
Okay. Thank you so much for your interesting presentation. I just like to ask, among those already established fiber, like maybe or you already familiarized with the dry fit fiber, dry fit fabric that already extensively in many sports big brand. Compared to your materials, yeah, what is the positions of your materials with those already available, like the one I've already mentioned, the dry fit fabrics in the sports apparels? That would be all.
Based on, thank you, Doctor. So I will be answering this question based on our observations on the market available, high quality and big brand sportwear. They are very less to yoga sportwear and also like the swimsuit. So based on our observations, we have this proposal nylon spandex, which is seldom found on the market, and it is very sticky, elasticity, and it is comfortable for the wearer on their movement. So on the market, we can find it is more like microfiber or only liner only, which is like not, which is more to like cycling wear or basketball wearing. So it is very less to find the sport wear, especially for yoga and also for swimsuit. Yeah.
Okay, thank you. Okay, thank you. That will be all from my side.
Thank you, Dr. Anissa. Maybe we can proceed with next question. Next question coming from next judge, perhaps. Associate Professor Wipo, do you have any questions for the team?
Oh, I try to follow the proposed from the student. I still have not clearing about the expanded. So it's already in the market, right?
Yes. Good morning, doctor. It's already have in the market, but it's seldom to see it and see the company to use it. Yes.
Oh, okay. So okay, I see that you show the using the expanded with the nylon for some clothes. So it is possible that we use the expanded to other fiber like cotton or something else. Is it possible?
Oh, okay. So that's why we introduced to use the nylon spandex is because nylon and spandex are the man-made fiber, which is made from the crude oil or the fossil fuels, which is more cheaper than we using the cotton this fabric. So this is the one of the advantages for the industrial for the company to use it. Yes.
I see. Okay, understand.
We actually have more 5 more minutes for the Q&A session. So maybe Ms. Cho Mi-Ling, do you have any questions for the team? Or maybe Dr. Steven?
Hi, good morning, students. Yep, that's a very interesting presentations about these nylon spandex materials. From what I can saw, one of the raw materials that you're using to create these materials involving isocyanate, right? So, and isocyanate is also known to have some hazardous effect. So how do you actually prevent this hazardous effect of this isocyanate to affect the wearers or the users? Any explanation on this?
Thank you. Questions. So, based on our research on this manufacturing process, we found that at the end of the reactions, they will be producing nitrogen oxide and also carbon emissions for the manufacturing, which is quite common among the industrial. So there are few suggestions that we give to this proposal is that we can try to give eco design for the manufacturing process. For example, we can try to reduce the oxygen concentration using during the process, and also we can try to reduce the combustion temperature. And at the end, by this amendment, we can lower the production of nitrogen oxide, which is one of the main pollutants at the end of our manufacturing. And also we can try to reduce the carbon emissions by using the fuel switching. Yeah.
And I also want to add some points. So besides our group discovered that there is an alternative sources that can replace the nylon, which is the Aquafil Econew. Actually, Aquafil's company introduced Econew as one of the alternative sources to replace the nylon, and it is actually the recycled nylon, which is the most similar form of the traditional nylon available, and it is made from the nylon that has been recovered from discarded fishing lines and other post-consumer waste floating in the seas, and then we can recycle it into the new, durable, and much more greener nylon. So when we nylon, we will reduce the emissions of the hazardous gases, and then we can recycle back, and then we can solve the other pollution problems there. Yes.
Yeah, thanks for the explanation. Yeah, it's good to actually make sure that every raw materials or the chemicals that we use throughout the production's life cycles is actually sustainable and also renewables. That can actually reduce the hazardous levels of these materials. Yeah, that would be good to know. Yeah, thanks. That's all for my questions. Thanks.
Okay, Doctor.
Thank you. That is all for our Q&A session. Now, I will move on to the next presentation. Let us welcome Polymers from University Malaya, UM, to present their project. Please welcome.
Good day, everyone. We are Group Polymers, which is the combination of polyester and gammarous. We are from University Malaya. We are going to present an interesting topic, which is functionalization of hybridized silver copper graphene nanoparticles on polyester for anti-COVID fabrics. First and foremost, let me introduce our group members, which are Loru Yi and He Chin Man. Both of us are second-year chemistry students in University Malaya. We are glad to have an associate professor, Dr. Harun Anwar bin Tajuddin from Department of Chemistry in University Malaya as our supervisor. On March 11, 2020, COVID-19, which is an infectious disease caused by the SARS-CoV-2 virus, had been declared as a pandemic by the World Health Organization, WHO. It is one of the deadliest infectious diseases in recent history. It is primarily spread person to person by small droplets or by contact with contaminated surface. The COVID-19 pandemic has led to a dramatic loss of human life worldwide and presents an unprecedented challenge to public health. 6.52 million people have died so far from the Maintaining social distancing and maximizing personal hygiene levels reduce the risk of transmitting the virus. But how can we prevent COVID-19 disease to a maximum extent? Let us find out together. Our project aims to manufacture an anti-COVID polyester. Copper, silver, and graphene nanoparticles are known as efficient on antivirus and antimicrobials. We predict that by applying silver, copper, graphene nanoparticles into polyester, it appears to have the same antiviral effects too. Polyester fabrics exist everywhere in our daily life. It is used for clothes, homeware, and even industrial application. It would be a great advantage to humankind and society if polyester could be coated with anti-COVID substances. Moving on to the chemistry behind our project, the silver nanoparticles are basically dependent on Ag+ ions. The main mechanism of silver nanoparticles is brilliant by inhibiting the replication of various nucleotides. It binds to the electron donor group such as sulfur, oxygen, and nitrogen, commonly found in enzymes within the microbe. This causes the enzymes to be denatured, and thus the microbe will quickly die. The Ag+ ion might work to deactivate SARS-CoV-2 virus like how it works in HIV and hepatitis viruses. Furthermore, the copper-based materials can be profitably used as part of preventive and therapeutic strategies in the fight against COVID-19 virus. The antiviral properties of copper have been known for centuries. It can withdraw nutrients to starve the invading microbes. As a proof, influenza A virus particles were significantly reduced on copper surface. It shows that copper-based alloys possess excellent potential in controlling the spread of infectious diseases. Here comes to the chemistry of silver copper nanoparticles. The metal nanoparticles can induce virucidal effects by blocking the cell virus attachment to the cells and entry of virus into the cells. Destruction of the outer layers of COVID-19 virus is one potential way of action of metal nanoparticles against the virus. On the other hand, Graphene is extremely thin and lightweight, and therefore an attractive material for nanotechnology applications. Graphene materials show excellent inhibitory antiviral effects against enveloped and non-enveloped virus, including RNA and DNA viruses. This performance indicates graphene-based materials can potentially combat coronavirus. Now, we will look into the manufacturing process of anti-COVID polyester. Here is our summary review of the process. Firstly, mixed colloidal solutions of copper, silver, and graphene nanoparticles can be prepared by mixing their dispersion. Based on previous research, the samples obtained by the dispersion process show smaller agglomerates in the presence of graphene than those obtained by melt mixing. This behavior can be related to high-energy ultrasonication in the dispersion mixing process. Silver-copper graphene nanocomposites could show some agglomeration with smaller platelets in the nanocomposites prepared by this proposed method compared to that prepared by melt mixing. Then, we will immerse the fabric and continue with ultrasonication to embed the nanoparticles into the fabric. Lastly, we proceed to the drying stage, where our textile is now functionalized. In our proposed process, we utilize sonication as a method of deposition of the nanoparticles. Ultrasonication is a process of applying sound energy to agitate particles or discontinuous fiber in a liquid. Sound frequencies greater than 20 kHz are usually used, known as ultrasonication. So, why is ultrasonication used? Ultrasonic irradiation as a new technology has been widely used in chemical reactions. When ultrasonic waves pass through a liquid medium, a number of microbubbles form, grow, and collapse in very short times, about a few microseconds. Ultrasonication generates alternating low pressure and high pressure waves in liquids, leading to the formation and violent collapse of small vacuum bubbles. This phenomenon is termed cavitation and causes high-speed impinging liquid jets and strong hydrodynamic shear forces. These effects are used for the de-agglomeration of nanometer-sized materials. Moving to the next part of our project, we expect that by manufacturing silver-copper nanoparticles and hybridizing them with graphene, we can produce anti-COVID polyester. When we have anti-COVID apparel, we can greatly reduce the percentage of people get infected by COVID-19 virus. The pandemic outbreak may end earlier than expected. It is also expected that this product has high antiviral effects to COVID-19 viruses and might be extensively used in medical. Thus, it may help in reducing the spread of COVID-19 to medical workers. Now, we are here to look into the project's impact. Firstly, our project, which uses the ultrasound irradiation method, provides quick and environment-friendly access to fabric nanocomposites, which have application in medical textile, catalysis, and materials for energy. It involves only the sonication of the fabric in aqueous solution and uses no hazardous reducing and stabilizing agents. Our project will use electricity to replace expensive thermal energy and chemicals which have to be treated in wastewater. We may reduce environmental pollution effectively. Not only that, but the significant impact of our project is also on high efficiency production. By applying ultrasound technology, we reduce processing time and energy consumption and maintain our product quality. We make our project cost-effective. Resultant nanoparticles are expected to be highly stable and reproducible. Lastly, the project's social impact is protecting humans from getting infected by the COVID-19 disease. Our project is also aligned with one of the Sustainable Development Goals, SDGs, which is good health. A society with good physical and mental health is what we hope for. To prepare the nanoparticles, we can synthesize silver nanoparticles and nanocolloid dispersion by reducing silver salts such as silver nitrate. Copper nanoparticles can be prepared by using copper-2 succinate as a precursor, and graphene oxide was synthesized by Hammer method through oxidation of graphene. However, it is suggested to use the commercially available nanoparticles colloidal solution due to the costly raw materials. As the table shows, the total cost of the raw materials is 72 ringgit and 50 cents per liter, and the operational cost for ultrasonic irradiation is 1 ringgit per liter. we can say that the cost is affordable and feasible for industrial scale up. To conclude, our project aims to manufacture anti-COVID polyester as an alternative way to prevent COVID-19 to a maximum extent. We tend to apply new technology to improve our product quality and ensure that it is environmentally friendly. We hope that we may contribute a little to overcome the pandemic outbreak. That's all from us. Thank you for listening. One last word. Together, we can make a better world.
Wow, she has an amazing presentation just now. Are you guys excited just now? I think everyone just excited and interested to learn more regarding polymers and fabrics. So thank you to Polymers. So I will now open the floor to judges to give any comments and questions for 10 minutes. Thank you.
Yeah, I just curious, throughout the whole presentation, you are talking about the nanoparticles. So can I know what is the size that you are talking about for these nanoparticles in the colloidal form?
It is about 20 nanometers to 100 nanometers. We are not using the quantum dots, which is ranging from 1 nanometer to 20 nanometer, but we are using 20 nanometer up to 100 nanometer. So the particle size is basically like that.
So you think it's big or small?
Small.
Small. Okay, so any commercial product actually available or apply this technology in the market right now? Example, maybe a face mask industry?
Yes. For now, I think the Malaysian market, basically, it already has the anti-COVID mask that we are usually familiar with. And also, I found out that the Pony Sedia Berhad, they also produce a product which is antibacterial for the baby wear. And our project was aimed to produce a fiber or a textile that is suitable for everyone. We are not only focusing on the mask, but also for the clothes, fabrics that can be used everywhere. That's our aim. Not only masks or the PPE that can only be used by medical workers in the medical area, but also everyone can easily reach it.
Okay, thank you.
Is there more in case?
Yeah, I have one question.
All right.
So right now, you propose that you're gonna use like 3 materials together, right? Silver, copper, and graphene, right? So how we can apply those 3 materials to the fabrics?
Okay, so I would like to answer this question. So basically, we mix these 3 materials together, and how we embed into the polyester, we are using the sonication method. So sonication method actually is a technology that will generate alternating high pressure and also low pressure. So when we generating the high pressure, the fabric particles will move apart with each other, and there is a chance, a small spaces, letting the silver, copper, graphene to embed into these fibrous particle. Yeah, and then when the sonication is going to the low pressure, the fibrous particle is moved to each other nearer again, so that the silver, copper, graphene will embed in the fabric forever. Yeah, maintain in the fabric. Yeah.
Okay. So how much we can add those material to the fabrics? The amount of the materials that we can put in the fabrics. Do you know that?
All right. So based on the research paper, we expect that like 100 milliliter of the chemical we use will produce 1 kilogram. So and also 1 kilogram of fabric will produce around 4.5 clothes. Thank you.
Okay, thank you.
I would like to add on how the particles embed into the fabrics. Like just now, my teammate, she is talking about the mechanical way, like how the nanoparticles embed into the fabrics. Now, I would like to explain more about the chemical bonding part. Actually, there are chemical bonding exists between silver copper nanoparticles with the graphene, which is the hydrophobic and van der Waals interaction. So this makes the hybridization of graphene with silver copper nanoparticles more stable, and the bond is difficult to break. So this further enhance the nanoparticles in the fabrics.
Okay, yeah. All right, thank you.
Steven, do you have any questions?
Yes.
Alright.
Good morning, presenters. Again, that's a very interesting presentations. So I have two questions. Maybe the first one I would like to ask is, since you are applying these nanoparticles to actually enhance the anti-microbial properties of the fabric, right? Do you have any testings or any result to be shown on the antimicrobial activity of these particles after incorporating into the fabric? How fast you kill the virus and bacteria like COVID-19 or this thing? Do you have any result to show?
So basically, based on the research paper that we found, actually we found silver copper nanoparticles that when they combine, so they will have the antiviral properties. So it is already proved in a research paper. And also for the antiviral properties, so that we can kill the COVID-19 virus by invading the nucleotide and also the DNA of the virus.
Okay, thanks for explanations. But usually, again, when we say we want to quantify the antimicrobial properties of a fabric or a certain enhancement that we've done, it's better we have some quantitative measures to do it. Like let's say, within hours, sometimes silver nanoparticles have antimicrobial properties, but after enhancement to a certain materials, so we need to know like what's the rate of it that can actually eliminate those bacteria or viruses. That would be an important indication for us to gauge how effective that material will be. So this might be something you need to look into. And a second question will be on the pricing, which I think you have shown earlier. And I saw that you put in the silver nanoparticles and the coppers, right? Is about 1 ringgit per liter. Am I correct? That to me is actually quite cheap, because as far as I know, the price of the silver nanoparticles and also copper nanoparticles should be higher than that. So may you elaborate like what kind of grade that you're using? Is it those industrial grade one or is lower than that? Because to me, one ringgit per liter of this silver nanoparticle is actually very cheap, right? Do you guys double check on this pricing?
So actually, we found it on the website, and actually we found through the Alibaba website. So the price is we found that is RM1 per liter. Yeah, for the industrial use.
Oh, like in that liter, like how much weight of this silver nanoparticles inside? Because usually we are talking about weight, right, instead of volume.
Yeah, we are using the silver nanocolloidal solution. So it's in liquid form.
Like how much percent of silver nanoparticles inside? Because it's in liquid form, it's not 100%, right?
So, just a minute.
Thank you to all the judges for your questions as well as your feedbacks and comments. And thank you again to Team Polyris on your presentation. We will now proceed with the next team called Sally the Duck from University Technology Petronas UTP. Please welcome.
Hello everyone, I am Farah Shina from University Technology Petronas. Today, me and my friend Ki Jun from Group Sally the Duck will present about our project entitled Polyionic Liquid Ionic Liquid Mixed Matrix Membrane for Carbon Dioxide Methane Separation. For today's presentation, I will start with the introduction, followed by the problem statement and the objective. I will also share with you our project activities, the project outcome, the impact of the project, and the ability for the industrial to scale up with the conclusion. Now let's move to the introduction part. For your information, mixed matrix membrane is the incorporation of solid phase in continuous polymer matrix. It is considered as a new generation membrane for gas purification application. Ionic liquid is liquid that contains cation and anion. Ionic liquid have been recurrently considered to be green solvent mainly because they show in general negligible volatility and non-flammability. Involved for polyionic liquid features species of ionic liquid in each monomer repeating unit, and macromolecular structure is formed by connecting through polymeric backbone. The significant properties of ionic liquids are included into the chains of polymer, and it leads to formation of new category of polymeric materials. On the other hand, carbon dioxide, which is the primary greenhouse gas responsible for about 3/4 of the emission, and it can linger in the atmosphere for thousands of years. Carbon dioxide emission act like a blanket in the air, trapping heat in the atmosphere and warming up the earth, thus raising concern on the alarming global warming. Therefore, one of the solutions being studied is using amino acid. Amino acid salt is a promising class of green material for carbon dioxide capture due to its extremely low toxicity, negligible volatility, and decent absorption capacity. With the amine functionality to capture carbon dioxide, amino acid shows huge potential and a good candidate to solve the issue. In this project, the synthesized ionic liquid are BMIM lysine and VBTMA glycine. The mixed matrix membrane are synthesized by using poly-VBTMA glycine with different loading of BMIM lysine, which are 0, 5, 10, 15, and 20%. Polyionic liquid will be synthesized using photopolymerization technique in the presence of 2-hydroxy-2-methylpropionone as photoinitiator and the vinyl benzene as cross-linker. Photopolymerization is the technique that uses visible or UV light to initiate and propagate a polymerization reaction to form a cross-linked or linear polymer structure. However, there are several issues identified. First, it is the presence of carbon dioxide impurities in the natural gas methane depresses the heating value, and carbonic acid will be formed in the presence of water that damage pipeline equipment. Next, the emission of carbon dioxide into the atmosphere from the burning of fossil fuel is also treated as one of the major factors for the global warming. Therefore, the objective of our project is to study the synthesis of BMIM lysine, poly-VBTMA glycine mixed matrix membrane, and next, to study the application of polyionic liquid MMM in carbon dioxide removal. Moving on to the methodology of the project, firstly, ionic liquids are synthesized by ion exchange method. 2 grams of VBTMA glycine monomer was mixed with 0 and 5% BMIM lysine and was stirred. Secondly, 63.7 micromilliliter of divinyl benzene and 17.6 micromilliliter of 2-hydroxy-2-methylpropionone are added to the mixture via micropipette. The resulting mixture is mixed thoroughly by using orbital shaker for 5 minutes at 480 rpm. After that, nylon supported, which is membrane filter, is placed onto a ring X-coated quartz plate. The resulting mixture is poured onto the nylon and casted between 2 quartz plates. Then, it is the photopolymerization process. Each side of the membrane surface was exposed for 30 minutes under 365 nanometer UV lamp at room temperature.
For the project outcome obtained, this is the proton NMR of VBTMA glycine. The synthesis of the monomer is considered successful based on the results. The peaks represent for the protons of the monomer structure are all shown. For FDIR results of the monomer, VBTMA glycine and the mixed matrix membrane, which is poly-VBTMA glycine with 0, 5, and 10 weight per glycine loading.
By comparison of the FTIR spectrums shown, the peak intensity of the functional group of poly-VBT-M8 glycine is higher than its monomer. This is due to the hydrogen bonding interaction in the functional groups during the photopolymerization process. And in spectrum for membrane of 0 weight % of beaming lysine loading, it shows a small peak at around wavelength of 2930. This is possibly due to the CH stretching vibrational mode of the methyl group present in the linker. And for example, in the spectrum of membrane with 5 weight % of beaming lysine, the peak at around 2180, it shows that there is hydrogen bonding interaction in the photopolymerization process, the concentration of beaming lysine. And the spectra of the membrane of 5 weight % and 10 weight % of beaming lysine, they do not present any peak location shift. So it suggests that there is no strong chemical interaction occurs between the components. And then for TGA results, there is a slight mass loss at around 100 to 200 degrees Celsius. This indicates that there is removal of the residual molecules, which is methanol. And the thermal stability of the membranes, they are less insufficient than VBT-M8 glycine because when it is heated to 800 degrees Celsius, the membrane experiences more weight loss compared to the VBT-M8 glycine. When it is heated to higher temperature, the polymer chain of the mixed matrix membrane, it will undergo degradation. And we can also see that the it undergoes the most thermal degradation, so its thermal stability is the lowest compared to the other membrane, and this also causes its low gas permeability. Other than that, we move on to the gas permeation study part. This is the equipment that we are using for the study. Firstly, we place the membrane on a membrane permeation cell, and then we seal it before connecting it to the gas stream. And the data, they were collected by measuring the amount of time taken for the gas to reach a volume of 10 ml. With the volume of gas measured with a bubble flow meter, and the time was measured with a stopwatch. And next, for gas permeation study, we will be using this formula for all of the calculation. Next, for CO2 permeability, we can see that the result, the membrane with 10 weight %, it has the best performance. We compare both of the result of CO2 and CH4 permeability. We can see that as the pressure increase, both of the permeability they decrease. And for both of the CO2 CH4 permeability results, membrane has better performance at pressure of 1 bar with 10 weight % of beaming lysine load. The impact of our project is that the mixed matrix membrane that we synthesize, it can be used for the application of CO2 CH4 separation. This step is important in many industrial processes such as natural gas sweetening, which is the removal of CO2 from the high pressure methane in natural gas works. And then biogas upgrading, oil recovery enhancement, and lastly landfill gas purification. Other than that, the ability of the industrial scale-up for my project, it is highly possible as the membrane that we synthesize, it can be tailor-made. Thus, it can be adjusted to a specific separation task. Next, it is the simplicity of the installation equipment and the operation process. And next, it is the power saving project as the consumption of electricity and fuel can be reduced. So, in conclusion, our mixed matrix membrane is easy to be scaled up, and it is also achieved the environmental awareness as it is made of the green polymers, which is the polymerized ionic liquid, the poly-VBT-M8 glycine. So, in fabrication of a good mixed matrix membrane, properties such as permeability and mechanical strength will need to be satisfied and considered in the project. The objective of the project are achieved. So that's all for our presentation today. Thank you and have a nice day.
Thank you so much for Team Sally the Duck for the wonderful presentation. I now open the floor to judges for any questions and comments, and a gentle reminder to everyone, Q&A session is only limited to 10 minutes. Thank you, and please welcome.
Okay, let me have the first question. First, thank you for your presentation. You're talking about the your membrane will use for the separation CO2 and what's that, methane, something like that, right? So what is a traditional method for separate that gas?
For our project, we're doing the CO2 CH4 separation, and the separation is based on the theory of the absorption and diffusion mechanism. The driving force for the separation of the gases, it is actually the pressure gradient. When a high pressure gas mixture moves across the membrane surface, it has a selective permeability to one of the component of the gas mixture. And the next factor is the presence of the amino acid and ions in our ionic liquids, which are the lysine and the glycinate. They also help to in the CO2-CH4 separation because of they in the NH group in their structure. They help reacting with the CO2 to form the carbamide and facilitate the transport in the ionic liquid based mixed matrix membrane.
Okay, yeah, okay, thank you.
Thank you, Dr. Vipo. Can we move to next question from any other judges, perhaps?
Hello? Sorry, hello?
Yes, Doctor. We can hear you.
Okay. Okay, thank you for your presentation. Can you please give whether you have already on the data about the effectivities of your membranes, yeah, to separate the CO2 and CH4?
Yeah, we have our result on the permeability, and actually for the CO2 CH4 separation, we can calculate the selectivity of the CO2 CH4 separation. The selectivity, it can be calculated by the permeability of CO2 divided by the permeability of the CH4. Based on our calculation, but I didn't show in this presentation slides, but from my calculation, I get that for the 10 weight % of the membrane, it has the higher selectivity, which is also has the CO2 and CH4 selectivity. So it means that the membrane with 10 weight %, it separates with 10 weight % of premium lysine loading, it separates the CO2 and CH4 the best.
Okay, thank you.
We have around 4 minutes left, so maybe another one questions for this team.
Yep. Hi. Good afternoon, presenters. Yep. That's a very interesting presentations on the mixed membrane system together with ionic liquid, right? So I have one question. Maybe my first question will be, well, we all know that this membrane system itself is already not that cheap. It's actually quite expensive, and some more now you are adding the ionic liquid to it, and we also know the ionic liquid itself mainly is on the cost itself is actually quite expensive as well. So have you done any cost calculation to ensure that this membrane is actually economical to be carried out in a large scale process?
Yeah, as we know that the price of the synthesis of the ionic liquid, it is quite pricey. But we also know that the ionic liquid, it is it is green because it is non-toxic, and by using it we can achieve environmental awareness by causing the less pollution, so we can actually save the cost on handling with the pollution problem. So although it is pricey, but I believe that the profit return that we can get from this synthesis of the membrane, it will be high.
I would like to add into that. I think ionic liquid is actually quite new to the industry. Like they are still in the process of introducing to the various technology. Even though this ionic liquid is quite high, I believe like there is further studies need to be done, because there are not actually studies done on this kind of ionic liquid. So there should be further study on how we could make this project to be more economical by reducing the price itself. Yeah, thank you.
Yeah, thanks for the explanations. My last question is on the thermal stability part of this membrane, because from the TGA result that you have shown, so there's actually quite a significant degradation that took place at a higher temperature. And we all know that in the separation of the CO2 and methane, sometimes in the industrial flue gas, for example, it might involve high temperature. So like how you can actually address these degradations, the thermal degradations of your membrane? How we can reduce it? Yeah.
For the TGA, when the membrane is heated to the higher temperature, the membrane will gradually decompose compared to the ionic liquid, and then the remaining weight is close to 5%, in which the thermal stability of the membrane is lower at higher temperature. And then the membrane at 5% has the lowest permeability, since it has lower thermal stability. So it undergoes thermal degradation at higher temperature, and the ionic liquid VBTMA glycine itself has better thermal stability compared to the membranes at lower temperature. Yeah, so at the first stage for VBTMA glycine, they have two stages. So for the first stage, it has slight mass loss, which indicates the removal of residual molecule. And then the second stage, it decomposes of the monomer acid, in which removal of the amine group.
Yeah, thanks for the explanations. Thank you. Yeah, that's all for my part. Thanks.
I would like to add on this, because based on the research study that we have found, from one paper we can also like change the amino acid and ion, because we found from the paper that when the anion size of the amino acid and ion size is greater, then its thermal stability will be higher too. So we actually can change the amino acid and ion for making the ionic liquid, so to get a higher thermal stability.
Yeah, that's very important, because in industry usually involve high temperature. Yeah, I appreciate the answer. Thank you.
Thank you so much.
I believe 10 minutes has passed. Thank you to our judges for all your questions and comments. We will be moving on to the next presentation, which is Pisang Lab from University of Debrecen to take the stage. The floor is yours.
Did you know that it takes 448 years for a face mask to decompose?
This is because the face mask is made out of petroleum base, which is polymer. Every polymer breaks down into microplastic and microfiber that end up at landfills and sea. This can be harmful to the environment, including human, animals, and marine life.
Everyone loves banana, but they didn't know that banana peel is one of the highest food waste.
How about we replace the use of the polymer in the production of disposable face masks with banana peel?
Compared to the face mask, banana peels only take 2 years to decompose. The question is it suitable?
Before that, let's get to know what is inside the disposable face mask. Disposable face masks have 3 layers. The inner layer is made up of a fibrous material, which is microfiber or nanofiber, which is depend on the particle size that to be encountered by the consumer. This layer helps to prevent the particles or droplet from the consumer to the environment. It also helps to moisturize the face from getting dry. Then we have the melt gusset filter, which is used to filter tiny airborne particulate from getting inside of the consumer nose and mouth. Lastly, we have the outer layer that is hydrophobic and usually is a non-woven material.
Banana peels have all of these properties. The inner layer of the face mask can be used by the inner layer part of the banana peel, as it is fibrous as well as moisturizes the skin. Secondly, the outer part of the banana layer has an antimicrobial property which can act as the melt gusset filter. This part is also water resistant or hydrophobic and can be used as the outer layer of the face mask.
We did experimental process to extract banana peel layer into 2, which is outer layer and inner layer. First, we took a banana peel and separated 2 layers using a knife. In this experiment, we took outer layer that has been removed from the fibrous part and tested with a few drops of water to prove if it's waterproof or not.
As you can see, we test both sides by adding water droplets. Indeed, the outer part of the banana peel is waterproof.
We tried to recreate the industrial process of the production of face masks by breaking down the outer layer as finely as possible. The purpose of this process is to make a pulp.
Therefore, we use a cooking blender to break the banana peel into small pieces. The water is added to make sure it blends smoothly.
Then, we took sifter to remove excess water from the pulp.
Next, we shape the outer layer on the tray and let it dry. This process is repeated using the inner part of the banana peel.
After 1 day, we tested with a few drops of water to the pulp of the outer layer.
In the first attempt, the water stays for a while, but then it flows through the pulp. While for the inner part of the banana peel, the water does flow through as we expected because the inner part can act as a moisturizer.
Then, we improvised by layering it on top of the filter. When we put a few drops of water, the water stays. From this observation, we believe that banana peel need another material that can support its function as waterproof.
Because of this observation, we also try to do the same process to the inner part of the banana peel. Hence, we also get the same result. This is the process for the production of face mask. Firstly, the raw material in this case will be the banana peel. As we did earlier, the banana peel should be separated into the outer and the inner part of the banana peel. However, this separation does not have any practical technique or machine yet, but we hope that it can be developed in the future.
Secondly, matte blonde process, especially for inner layer. The matte blonde process creates a fine fibrous and soft bonding web by using high velocity air to blow molten material from an extruded die tip onto a conveyor or take-up screen. A combination of entanglement and cohesive sticking work together to lay the fiber in the matte blonde web together. Hooper, extruder, measuring pump, die assembly, web formation, and winding are the components of this process. Pellet or granule of the raw material are fed into the extruder hopper. The meter pump delivers uniform melt to the die assembly with positive displacement and constant volume. It guarantees steady flow of a clean polymer mixture despite viscosity, pressure, and temperature fluctuation in the process. The most crucial component of the matte blonde process is the die assembly. There is a 3 separate parts, which is the polymer feed distribution, die nose piece, and the air manifold. For 2 reasons, the feed distribution in a matte blonde die is more important than in a film or sheeting die. First, there are often no mechanical modification to the matte blonde die to account for differences in polymer flow across the die width. Second, the process is frequently run at a temperature where polymer thermal breakdown happens quickly. The feed distribution is often made so that the material distribution depends less on the polymer shear characteristic. The polymer melt goes directly from the feed distribution part to the die nose piece. The web uniformly hinge largely on the design and fabrication of the nosepiece. The high-velocity hot air, also known as a primary air, is supplied via a manifold through slot on the top and bottom side of the die nosepiece. High-velocity hot air stream that exit from the top and the bottom of the die nosepiece reduce the polymer stream as soon as they are extruded from the die hole, causing microfiber to be produced. The use of additional bonding such as heat bonding is used to change the features of web in addition to the fiber sticking and entanglement that occur at a laydown.
In contrast, a technique for creating polymer laid nonwoven is spin bonding, based on the melt spinning method. Spin pumps use a spinneret with a lot of holes to drive the melt through. The spinneret blocks quench air ducts continuously feed conditioned air to cool the filaments. Additionally, there is a constant flow of auxiliary room temperature air. Ventilator generated under pressure pulls the filaments and mix air down from the spinnerets and cooling chambers along the entire operating width of the line. The through adventure, which is a high velocity low pressure zone to a distributing chamber, which affects fanning and entanglement of the filaments. The turbulence in the airstream causes randomness, while the moving belt's directionality causes a slight bias in the machine's direction. The area below the sieve belt improves how the filaments are laid down. The spine bonded web is subsequently transported to the bonding zone by the conveyor belt. Depending on the material and the required qualities in the finished fabric, the web is then bonded using either thermal, mechanical, or chemical means. For many applications, thermal point bonding is the most widely utilized method. For your information, in the melt blown process, hot air converges with the fiber as it emerges from the die, whereas in the spin bond process, the hot air flow is at the cross flow to the emerging fiber. In this last process, these three layers of face masks will be stick together by some kind of binding material through bonding technique. This face mask should be packed in a vacuum. This is because banana peels have the properties to decompose. However, it can be kept for a long time if it is packed in a vacuum.
Costing. First, banana peel will utilize from production factories such as food industry, etc. Second, reduce the usage of petroleum based as it non-renewable sources. Based on our finding, we believe that these are the SDGs goals that can be achieved. According to Goal 9, since there are no practical technique to separate the banana peel, this goal can be achieved as it can enhance industry to be innovative about this new technique.
For Goal 12, as we use banana peel as the raw material, we will be able to reduce the wastage in general, as banana peel is one of the largest contributors in the food wastage.
Moreover, the current face mask products are made out of the petroleum-based material. By using banana peel, we can reduce the pollution of petroleum production as well as maximize it for the future use. This is based on the Goal 13.
Face mask pollution also has been a big issue and can be harmful to marine life. By using banana peel, it will be more environmental friendly as it is not harmful to marine life according to Goal 14.
Lastly, banana peel has many nutrients, hence it can be used as a fertilizer when it's decomposed. This can help the plant grow for plantation when it's not used anymore, so Goal 15 can be achieved.
This is the whole summary of our findings. Without hesitation, we believe that banana peel has the potential to replace the polymer in the production of disposable face masks. By the end of the day, we can reduce the wastage of disposable face masks as well as utilize banana peel.
Thank you, Pisang Lab, for the incredible presentation. I would like to invite the judges to give their comments and questions for 10 minutes. Please welcome.
I would like to know how many kilograms of banana peels were used to make for one piece of face mask, and also the process actually take how many hours or days?
Hi,
Thank you for the question. My name is Emilia. So for that question, based on like our research and reading, we didn't use for the kilo, but we know one banana peel can produce starch that we need to need to produce for PLA is between 16% to 15%, and for one granule needs for 6%. That granules or platelets that we need to produce for the plastic, which is for the big layer of fiber. So for one layer for face mask is need for from 30% to 24%. But as we know, the face mask have 3 layers, which is inner layer, middle, and the outer. So we can estimate 3 banana peel can produce 2 face masks. And for the how long process that take to produce the from banana peel to pellets or granule plastic, it's same as a bio-based material process as existed. It's just like we change the type of bio-based material to banana peel. Okay, thank you.
And the second question about how long does it take? We are not sure the exact time, but I'm pretty sure it will take same process as making a plastic pellets. So maybe it would take around for 1 kg, maybe only 1 month or something like that, because we only extract the starch from the banana peels. So that is only the additional part of it. But other than that, it's just like making a bioplastic and something like that, because as we know, face mask is made from petroleum-based material. So it's the same process as making face masks.
How about any particular species of banana? You know, banana, we have a lot of species, right? Are you particular for just one type, or any banana species also can?
We're focusing on getting extraction from the starch, and the starch here is the raw material. So from the starch, we extract the starch from the banana peel by heating, and from here we hydrolyze it to become glucose. PLA. So PLA is the base material on making plastic or face mask, because it's also kind of like a substitute for bioplastic.
Yeah, and also I want to add is a type of banana, but for now we also based on our research is just we general for the banana that we found in every Southeast Asia, because in Malaysia we have a type of banana like I'm sorry for say it's like I don't know in English it's like pisang berangan, pisang manis, but we know we just take the like I call this the monkey banana, the big one, but not the pisang tanduk. So it's just my estimate. Our research and reading is based on that type of banana. Okay, thank you.
Okay, that's all from my side. Yeah.
Okay, let me have questions for you. What the banana peel property you expect for use for the face mask?
So firstly, as you see in the video, we actually try to confirm that banana peel have a waterproof property, because nowadays the face mask that we use is actually have a waterproof property, so that virus or something outside can't go through our face and nose and mouth. But when we do the experiment, it doesn't really show that it has a waterproof property. But with the help of coupling agent, as we do reading, we think that with the help of coupling agent, it can help to improve the properties of waterproof. So that's the first properties, and the second property is that we believe that banana peel have an antimicrobial property, and it's same as a face mask, which is when we use in surgical or food industry, we want to make sure that bacteria don't from our part didn't go inside of the food or
someone's body while doing surgery or something like that. So we do some research and we found out that banana peel have that property, and that is why they are called banana peel, because they protect the fruit inside so that we can eat fresh. So that's what we get from them.
All right. Okay. Thank you very much.
Is there any question from Dr. Steven or Dr. Anissa?
Maybe I would like to ask, how about the mechanical properties of the these banana peels?
About the mechanical of the fabrics from banana peel. Okay.
The
so,
mechanical properties.
Okay. I try to answer this question. What I read is because that we use the same process as a melt bound and spun bound, so it will produces the for the middle layer it will produced by the melt bound, so it's have the weak fabric, so which is a good properties in the sugar in face mask. And for the outer and inner layer, they have strong fabrics. They are fabric which is a good for filtration properties. And is it mechanical include for the strength and things?
About the strength, we have seen read some papers and also do some readings. You say banana peel have the same strength, almost as the same as plastic. So we believe that if we can use banana peel as bioplastic, since some people already do this for bioplastic, like the plastic bag that we use nowadays. So we believe that it can also use in face mask, because face mask is have the same strength with plastic, with the plastic bag. So we think that banana peel have the strength to be a face mask. So that is in terms of strength.
Okay, thank you.
Okay, hi, good afternoon, participants. So I think we still have time for one questions, right? So my question will be, since you're going to synthesize these banana peels as one of the material for the face mask, right? Have you done any studies on the gas permeations of this banana peel face mask? Like how fast you transmit the gas, because you know this face mask we're going to use it to for respiration. So the gas transmissions and what type of gas that can go through and those that cannot go through will be quite important. So have you this kind of data, like what how fast the gases like CO2, oxygens, those that can pass through this face mask?
We're not really do the experiment, but we do some reading. So far, what we read is about banana fabric. Banana fabric composed of different type of banana parts, like the roots and the leaves. But we don't really have data from the banana peels. But based on the banana fabric, it is breathable. Some air can go through, but compared to the nowadays, the face mask that we use they only protect us from dust, like heavy dust or something like that can carry microorganism. So compared to the banana fabric, it does protect us from heavy dust going inside our nose or mouth. So we believe that banana peel have also that property, since some parts of banana fabric consist of banana peels, and also other parts of banana trees also have the same kind of composition with banana peels. So yeah.
Yes, and I want to add that because we focus this banana peel to replace for the face mask, not for like another type of face mask like N95 or something that have like advanced properties that can protect us from like you said gas emission or something.
Okay, thanks for your explanations. Yeah, I think it's good that you can actually have further study on this because if even you talk about dust, then we have actually some standards like PM22.5 and PM10. So we might need to know like what kind of particulate matter that you are talking about that can pass through this mask. Yep, that's all for my questions. Thank you.
Thank you to all judges for the questions, and thank you for Pisang Lab team from University of Debrecen. I'm sorry if I pronounced it wrongly, but your presentation was entirely interesting. Now we will move on to the very last presentation of the session. And for that, I would like to welcome Hexagro 2.0 from Taylor's University for their presentation. Please welcome.
Food delivery and takeouts are on the rise as new online platforms such as GrabFood, Shopee Food race to capture market with discount, free delivery, and more. Based on Fortune Business Insight analysis, the global food packaging market is projected to grow at 338 billion in 2021 to 478 billion in 2028 at a CAGR of 5.1% in forecast period. With the ongoing pandemic, this has also caused a spike in restaurant takeout containers, owing to the increase of food safety crisis. Among various food packaging variants, styrofoam, plastic, and paper food packaging are the most common packaging used in our daily lives. This food packaging usually lands up in landfills, causing environmental pollution.
Out of the million tons of plastic produced in Malaysia, almost half of it derives from packaging materials. Food packaging waste statistics point to a significant problem in our society. In 2020 alone, Malaysia used an estimate of 148,000 tons of plastic packaging for food. We are contributing to the issue of climate degradation when we produce and throw away these containers. Much of the plastic that doesn't make into the recycling plant ends up in rivers and oceans. Not only this is a danger to the animals and plants, the habitat has become aquatic garbage patches, but it also poses a threat to the climate. Release greenhouse gases which slowly breaks down. Sunlight and heat cause it to release more ethane and ethylene. Next, styrofoam contains styrene, which leaches into the foods and drinks served in styrofoam containers, causing contamination. When the same container is exposed to sunlight, it creates harmful air pollutants that contaminate landfills and deplete the ozone layer. When styrofoam is being manufactured, the process releases large amounts of ozone to the atmosphere, causing respiratory and environmental issues. Mass-produced paper packaging, deforestation is required to obtain the paper pulp, which may cause landslide and habitat loss to animals.
To solve the issue, we are introducing Hexagro, an all-palm fiber-based biodegradable food packaging.
These are the 8 steps to turn the palm fiber into paper sheets. Palm fiber was then washed thoroughly here. Then, the washed fiber is then dried in an oven at 50 degrees for about 2 hours. Next, fibers will soak in 2% of NaOH for 48 hours. Sodium hydroxide helps to facilitate the removal of lignin, hemicellulose, impurities, wax, extracting from the fiber surface. This is to ease the blending process. Before blending, starch is added to improve the water resistance. The soaked palm fiber was blended until a thick paste is formed. Then, the blended palm fiber is poured into a tub of water. A mesh is used to drain the palm fiber into thin sheets. Then, the palm fiber sheets was gently transferred onto a dry towel to absorb the excess water. Then, the sheet will be dried in an oven for 50 degrees for 2 hours. The sheet will be hot pressed. This is to enhance the binding between different components of hydrogen bonds of microfibers. Next, a paper box template will be printed on a paper sheet. Scissors are used to cut out the sheet. Lastly, the paper sheet will be folded according to the template lines into a box shape.
After the R&D process, product design and testing will be conducted. Mechanical testing to test the durability of the packaging and water resistance tests to check whether the packaging will leak are essential. Other tests such as food safety tests and biodegradability tests will also be conducted during this period.
With that, we plan to outsource suppliers such as small plantations to provide palm fiber.
We'll be able to process fiber pulp for mass production in factories. The steps involved in pulp and paper making procedure of palm fiber sheet is similar to paper making, hence we'll be using the same process. Firstly, palm fiber that has been received at the pulp mill will be screened for size, cleaned, and temporarily stored for further processing. Then in the fiber separation stage, several pulping technologies will be diverged. The fiber are kept into a large pressure cooker, also known as the digester, into which is added the appropriate chemicals for chemical pulping. After the digestion process, the cooked pulp is discharged into a pressure vessel. After that, this cooked pulp is returned to the chemical recovery cycle. In the second stage after refining, the pulp is screened, cleaned, and most of the processed water is removed in the preparation of paper making. Bleaching agents are added along with sodium hydroxide. A strong alkali is used to extract the dissolved lignin from fiber surface. This is to improve the interfacial bonding of fibers. This is done during the bleaching process. After that, the bleached pulp will be further refined to cut the fibers and soften the surface of the fiber to enhance the formation and bonding of the fiber as they enter the paper machine. Then water is added into the pulp slurry. The dilute stock passes through a head box that distributes the fiber slurry uniformly over the leaf of the paper sheet to be formed. Then at the press section, excess water will be removed and help the smoothness and bonding of sheet. Then the paper is dried and rolled out using a paper reel. Next, paper rolls will be sent into food packaging factories to process the boxes and delivered to customer or retail shop.
Now back to our project timeline. We are planning to give out free samples of the fiber food packaging for free to allow the public to test the product. During this period, we will also start our social media, website, and awareness campaign to build awareness to the public, which allows them to know more about our products. In the start of the business, we will be doing direct selling to customers and through online platforms such as Shopee or Lazada. Our targeted market are eco-friendly F&B businesses and the youth and middle-aged people.
Malaysia is one of the biggest oil palm manufacturers and it has generated 15.8 million tons of fiber waste every year. We are using this unwanted waste and turning it into a food packaging. We are providing Malaysians with a better alternative of biodegradable packaging as it takes an estimated of 90 days for the palm fiber to compose. A more durable and protective food packaging is proposed to the public as palm fiber has higher tensile strength than paper packaging. The physical intertwining between the short and long fibers increase the mechanical strength of the molded pulp packaging.
The phase transition of the remaining hydrophobic lignin also contributes to water resistance and stiffness of food packaging. This allows food to be stored for longer duration without it leaking or spill.
In conclusion, we have successfully created a prototype made from palm fiber using the sodium hydroxide chemical method. With the properties from palm fiber, it has shown to have a better durable strength and water resistance. Palm fiber is biodegradable, which contributes to reducing environmental waste and does not pollute the environment. There is still room for improvement, as other substances such as wax and other enzymes can be added to further increase the tensile strength and water resistance of the product. We hope to spread awareness about environmental issues and how waste can be reduced to make innovative products. By using this product, we hope that we can make a winner. Growing green starts with you. Thank you.
Thank you so much, Isacro 2.0, for your impactful presentation. Now, I will pass the floor to the judges for any questions and comments. Just a reminder, Q&A session is limited to only 10 minutes. Thank you. Is there any question from the judges?
Hello, good afternoon, participants. Can you guys hear me? Oh, okay, good. So maybe I'll start first Okay, well, this is a very interesting concept of using the palm oil fibers to actually create sustainable packaging materials. As we all know, the food packaging materials is a large contributor to the waste product that we have. So my questions will be, of course, the palm oil plantation itself, we know that during the plantations and the growing phase of the oil palm trees, there will be some chemicals that will be using, such as pesticides, fertilizer, all these things. So just wondering if there's a chance that this kind of hazardous chemicals can actually retain inside the palm oil fibers during the packaging process and might be harmful to the food later on. So what's your opinion on this? Hello? Do you get my questions clearly? Yeah, because we all know that there's fertilizers and pesticides used in the palm oil industry plantations itself. So I'm just wondering if there's any chance to eliminate these hazardous chemicals during the synthesis into the packaging material so that it won't contaminate our food. Yeah. Any suggestion or opinion on this?
Because when they produce the oil palm, they actually like already like grind the oil palm fiber, especially the empty fruit branch fiber. They grind already, then we are only taking that waste to produce food packaging. Also, we will wash and also add some chemicals to wash it, especially the bleaching process to make it like food safe.
Okay, but can you ensure those hazardous compounds be 100% removed before you make it into the packaging material?
This one we cannot guarantee because we only make a prototype, and then like we get our prototype from those we get our prototype palm fiber from those gardening shops, so it's like it is like not so like not so dirty, so yeah, cannot guarantee.
Okay, yeah, I think I can suggest you to actually done more characterization on this packaging to see like what is the chemical compound that might still exist in there. So if it's really safe for human consumption, then I think it'll be a good candidate for food packaging materials. Okay.
Yeah, we also try to like find oil palm factory to give us the fibers, but then until now they haven't give us a reply, so we can only get it online. So we also cannot do all these tests for now.
Okay, yeah. So I do know several palm oil mills so if you really want to get some source, maybe you can contact me later on. I can help you to actually link up to them see whether they can willing to give you or not. Okay.
Okay, thank you.
Yeah. Okay, that's all for my questions. Thank you.
Okay, let me have some question about the packaging from the natural fiber. That really interesting. Okay, when we make some packaging for food, sometimes we have like the water, so it has the waterproof or water resistant for the natural fiber packaging.
For this prototype, we did not add any wax. For our final product, we plan to add a layer of wax so that it will be waterproof, so that you can put like liquid or sauces inside the food packaging.
Oh, I see.
Yeah.
All right. Yeah. Thank you.
Thank you.
Is there any more questions?
Dr. Anissa, do you have questions for them, or do you not have questions for them?
Hello. Yeah. I'm sorry. I hope I'm not repeating any question because I kind of hung out from this room. Okay. One simple question. How are you going to make sure that the process of your uh, producing, your producing process would be free from the bacteria? Yeah, because this is basically a packaging from the from food. Yeah. Do you have any steps that maybe that you can uh, present, yeah, about the steps that in the production stage that ensure that your product is doesn't bring any bacterial contaminations into the food? That would be all. Thank you.
Hi, thank you for your question. So you're basically asking how we mass produce into food packaging, right?
Yeah.
So basically, it's quite similar to paper food packaging. So when we grind it into pulp, it's quite similar to the paper food packaging. So we're outsourcing into contacting paper food company so that they can help us use the pulp and then mass produce into paper sheet. Then we can use it to cut and then fold it into food packaging.
I believe there is no more question from the judges. Thank you very much to all the judges and a round of applause to all of the presenters in this session. I hope everyone took all the good point and amazing presentation for all of the teams. Congratulations again. To our honorable judges, I appreciate if you can email the result via email to Nurul Saida by 1:15 p.m. You may find the email in the chat box.
Ladies and gentlemen, we are going to take a short break for lunch and to give time to our honorable judges to deliberate the scores. But before that, please click on the return button on the right screen to return to the main room if you are not directed to the main room. And with that, do not forget to join us back at 2 p.m. as there are going to be amazing prizes awaiting for all of you by participating with our mini games quiz session later. Enjoy the lunch break, enjoy the break. I'll see you guys back at 2 p.m. Thank you and have a nice day.
Okay,
thank you.
Thank you, Dr. Anissa. Thank you, Assistant Professor Vipro. Thank you, Miss Chovy.
This because I have already another appointment, so the session after the lunch break is not compulsory for the judges, right?
Doctor, can I get a minute to reconfirm and then I'll tell you right here.
Thank you, everyone. Bye-bye.
Bye-bye.
Thank you. Bye.
Welcome, Dr. Anissa. It is not compulsory for the judges to join the closing ceremony. You just need to email the result only.
Okay.
Thank you. Have a nice day.
Okay.
When you have that 8-month period, companies and also the leadership team of that place where you're interning in are more likely to give you projects. So everywhere I've gone, they all say, wow, UTP internship program, #1, the best. And I agree, without that 8 months exposure, I do not think I could have as easily, I wouldn't have been as ready for the industry right after graduation. And just to share, less than 1 month after my graduation, I did manage to secure a job as a reservoir engineer at ExxonMobil. And what the feedback that I got was that, it seemed that I was very prepared to join and work and contribute to a corporation and to an organization. And I don't think I would have been able to do that without that industrial experience.
I would like to wish happy anniversary UTP and thank you for all these amazing 5 years and for all the opportunities and chances that you have given me.
Since our inception in 1997, UTP is committed to fostering collaborations and partnerships with the industry. Together with our partners, we edge towards sustainable global prominence, a unique feature of our global prosperity action and identity.
Explore what is the true potential within me.
I am glad that I managed to continue my passion in rugby sports that I've played since I was 16 years old and became the team captain for UTP G Drillers Rugby Club.
From organizing the event, being the MC in the concert hall, leading the International Student Representative Council, managing a football team, forming a music band with friends and competing at the national level, to representing the university for the petroleum engineering quiz competition. Who would believe that it all would happen in just a few years in UTP?
When we developed this university some 25 plus years ago, we call it a dream. To produce students with holistic education so that they can contribute to the future success of themselves, their careers, and ultimately to the global good of the world. So it was a big dream, and the dream continues. Let's carry on with the good work. Let's continue with all the things that we believe in, and God willing, success will be achieved.
At UTP, unlocking true potential is one of the major life possibilities that we seek to create. In this respect, we will continue to sustain our unwavering efforts in producing relentless, creative, and innovative graduates. Thank you for being part of our journey. Here's to more years of energizing futures.
Applied chemistry is in our everyday lives. We see chemistry in almost everything. For example, the air we breathe, the food we eat, and even the fuel that powers up our cars. Chemistry is important because we see it in our everyday lives, and everything we observe is due to chemical reactions. My best UTP experience, I developed a catalyst to convert carbon dioxide into methane. And aside from my FYP project, I also managed to lead student organizations such as the Society of Petroleum Engineers student chapter, where I was elected the Deputy Vice President.
I did my 7 months of internship at Japan. The experience is very amazing and very great. I'm doing the research is regarding about the deep utility solvents using as a catalyst or as a co-solvents as well to enhancing the biodiesel production.
Chemistry is an important part in any future industry. Thanks to UTP's strong industrial linkages, as well as the wide range of expertise, I can apply what I've learned in the industry.
Backed by strong ties with Petronas, the parent company of UTP, the graduates from this program is able to tap onto that opportunity and enter into the oil and gas industry in Malaysia. The content of the program allows some level of versatility for the graduates to explore beyond the oil and gas industry in Malaysia. So it pushes the boundary to explore all other job options available in the country and also regionally and so internationally. So that makes UTP graduates high-value graduates.
As you know, in our applied chemistry course, for the first 3 years, the student will be doing fundamental chemistry. They also will be doing some computational chemistry. So after the 3 years, they will do a specialization package where they can do research projects. So in this research project, they can do either in environmental, they can do in catalysis, they can come up with new materials that can reduce pollution. After they have done this research, we believe this will equip them to go into the job market. In Malaysia, a lot of companies are looking into chemistry who has knowledge in this area. So we believe in UTP, we will prepare the students for this job market that is not only today, but will be useful in future.
UTP Applied Chemistry Program received prestigious accreditation from the Royal Society of Chemistry, or RSC, positioning the program to be internationally recognized. This provides assurance to employer and students in a competitive global job market. The RSC recognition also gives opportunity to students and academic staff the Mobility in Exchange program among the RSC accredited institutions worldwide. The Applied Chemistry program in UTP also offered 3 specializations, namely petrochemistry, sustainable chemistry, and nanotechnology, to cater for the Industrial 4.0.
The youth is important in Malaysia, and it's very important for us to ensure that they can participate in Malaysian well-being. So besides securing a job, we want to also get the students involved in the nation's issues, especially in environment, in pollution, in coming up with alternative energy. In UTP, we believe our course is preparing the students for these areas. When the students make a discovery in the lab, especially the light in their eyes when they find a discovery. So, and many times these students have made useful discovery, which we are using it for our research project in later years. Coming to UTP is a good step for our youth to take up, especially the applied chemistry course which we are offering here. Join us. Together we can dream up new possibilities.
To those of you who have come in search of answers, seeking inspiration and looking to achieve your aspiration, this is the place where you will learn to find the answers, where you will be motivated to discover your inspiration, where you will be propelled to realize your aspirations. With today's global challenges, the role of the engineer, the scientist, and the technologist is transformed from being the technical innovator into being the agent of global change. Our world-class resources and faculties, our cutting-edge facilities, our global partnerships with leading universities, our strong network with industry for internships and job placements, these are the inspirations and the opportunities at UTP. Analytical skills and intellectual capabilities of all who walk the UTP path. Here we culture the ethics and the attitudes that will shine in the real world. Here we expose ourselves to what it truly means to be human, to be a valuable part of society, to be the empowered people, the game changers who will light up the path towards a better world and change lives for the better. At UTP, the torch is firmly in your hands. So hold it up high and let us together light it and let it burn brightly. Join us to seek inspiration and achieve your aspiration towards global prominence.
doing?
Hi, great.
What's your name?
Kang.
Kang.
Nice to meet you.
Where about you? From Malaysia, right?
Yeah, I'm from Malaysia.
Excellent. How long have you been here?
About 4 months. I'm working on composite manufacturing, so I've been given a chance to work in the composite laminating room. Currently, composite manufacturing departments would like to implement a new technology into the composite laminating, whereby they use the laser positioning technology to reduce the time needed to manufacture this rooftop wishbone.
First time you working with CAD? Or
No, I learned some bits, pieces in university.
What can you take home with you?
Yeah, definitely is the teamwork. Yeah, and they helped me to develop my skills bit by bit.
Excellent. Well, I hope your experience here has been great. And
yeah, it's great.
Hope the next 2 months you learn a huge amount so you can take back with you.
Yeah.
And you'll always be welcome back.
Yeah.
All right, buddy.
Nice to meet
you. And you. How you doing?
Hi, nice to meet you. My name is Praveen.
Praveen, nice to meet you.
Yeah.
How's your stay been?
It's been great so far.
You've been here for 4 months, right?
Yeah, since January.
Excellent. What have you been working on?
So I've been working in aero inspection, mostly because my supervisor, Michael Fuller, is in charge of that. So what we do is inspect all the parts before it goes to the model shop. I'm using like scanning equipment to scan the parts, also manual checks on the car.
So do you know what you want to do though in the future?
Not really.
Not yet.
I still have 1 more year to decide.
Okay, excellent.
Yeah.
Excellent. What's your favorite part of the Formula 1 car?
It has to be the front wings because they keep on changing it in the aero to make it faster and faster.
You're over in the by the wind tunnel. All those guys are the best.
Yeah, I've seen you a few times there.
Yeah, I like going there, and I'm going to go there today as well. I like to just go and see what's happening with the car. Well, I might see you there later on anyways.
Yeah, I think so. Catch you later.
It's a place that gives me opportunity for higher education.
Above expectation. Having graduated is also yet another memory. Most memorable experience for me was celebrating my lecturer's birthday because the community that time was very small. We were very close.
The good memories that you can have in the universities. There are many good friends that I still keep in touch with and I still have. So I think university days are more than just knowledge and skills and career, thinking about future. But college days is really something that's shaping our life.
My most memorable experience, we have this like a family of our I think it was 7, 8 of us, very close. So all of us are still in touch until today. I'm going to have our mini reunion soon. So yeah.
What I enjoyed most is actually kayaking. We spend a lot of time outdoor and spend a lot of time
and teach thousands of new students the UTP song during the orientation week.
UTP is very special to me because I come from a very humble background. Thinking of stepping into a university has always been quite a far-fetched dream.
Place that that teach me the analytical skills, the skills that is needed so much in my life.
My years at UTP were some of the best in my life. I walked into the real world as a UTP graduate feeling extremely confident.
What I like most about UTP is it's a melting pot of cultures. Particularly the environment here is very nurturing, very good for education actually.
Download Korean drama from another where. Then so we just watched Korean drama because nothing to do in Toronto.
I created and organized UTP's major events that have now become the university's annual functions.
In 2019, I won the Prestige 40 Under 40 Award. I must say that that award was given because of contribution towards different areas. So how did I get into this part instead of just focusing on engineering is because of my experience in UTP where I was exposed to social developments through CSR programs.
just like how I did with my IT, whatever I do up until today, I designed everything. If you look at kindergarten, I designed it. If you look at the school, I designed it. So I'm proud to say I'm the product of UTP. At least I bring that with me.
My advice to UTP students, first,
do well, up your performance. Most importantly, be passionate about life. Find the purpose and meaning in your life as you will venture out in your working life later.
To all UTP students and graduates, I just want to let you know how proud I am to be a part of the family. May we always keep up the tradition of being resilient, creative, and excellent.
Thank you, UTP, for unlocking the potential in me and shaping who I am today. I will always have UTP in me wherever I go.
For 25 years, UTP has played a significant role in taking the nation, industry, and society forward. As we eye a greater shared future, our graduates, stakeholders, and community are in line to be the makers that push reality-defying growth and innovation. Welcome to our 25-year story of energizing futures. As a result of our 25-year experience, our well-rounded graduates and global citizens embrace the power of initiative to excel in the most demanding atmosphere of integrity, accountability, and innovation. Everywhere around the world, UTPians pave their success by making meaningful contribution to global industries as leaders of current trends. Based by our strong industry network, this gives UTPians a competitive advantage that gets them career ready even before they graduate.
UTP gave me the opportunity to really test myself and expand my horizons. Through my experience in UTP, I organized multiple volunteerism events, one of which even took place in Vietnam. From the moment you join UTP to the day that you graduate, that experience is one that will benefit you. It will change you as a person, whether you're a student or whether you're a staff. And these experiences give you lessons that will be embedded in you throughout your whole life. Hence, UTP in me.
As the world moves rapidly, UTP strives to be a leader in technology and education, as well as a center of excellence for creativity and innovation.
I think the most memorable experience is how we, the students, work with the lecturers and staff to pioneer new things. During my time, there was no clubs or student activities yet. So we started organizing activities, setting up clubs, and so on. We built the platform together, so to speak. Those are invaluable experience for me. When you don't have it, create it.
Research and development, R&D, is one of UTP's flagship core drivers. It has become a familiar hallmark of progress and prestige for the university. For 25 years, UTP's R&D activities have constantly returned many tangible benefits to the nation, industry, and society.
When you have that 8-month period, companies and also the leadership team of that place where you're interning in are more likely to give you projects. So everywhere I've gone, they all say, wow, UTP internship program, #1, the best. And I agree. Without that 8 months exposure, I do not think I could have as easily, I wouldn't have been as ready for the industry right after graduation. And just to share, less than 1 month after my graduation, I did manage to secure a job as a reservoir engineer at ExxonMobil. And what the feedback that I got was that, it seemed that I was very prepared to join and work and contribute to a corporation and to an organization. And I don't think I would have been able to do that without that industrial experience.
I would like to wish happy anniversary UTP, and thank you for all these amazing 5 years and for all the opportunities and chances that you have given me.
Since our inception in 1997, UTP is committed to fostering collaborations and partnerships with the industry. Together with our partners, we edge towards sustainable global prominence, a unique feature of our global prosperity action and identity.
UTP is not just a classroom, but a real-life, career-integrated learning environment. It allowed me to explore what is the true potential within me.
I am glad that I managed to continue my passion in rugby sports that I've played since I was 16 years old and became the team captain for UTP G Drillers Rugby Club.
From organizing the event, being the MC in the concert hall, leading the International Student Representative Council, managing a football team, forming a music band with friends, and competing at the national level, to representing the university for the petroleum engineering quiz competition. Who would believe that it all would happen in just a few years in UTP?
When we developed this university some 25 plus years ago, we call it a dream. The dream was to have the best engineering school in this part of the world, to produce students with holistic education so that they can contribute to the future success of themselves, their careers, and ultimately to the global good of the world. So it was a big dream, and the dream continues. Let's carry on with the good work. Let's continue with all the things that we believe in, and God willing, success will be achieved.
At UTP, unlocking true potential is one of the major life possibilities that we seek to create. In this respect, we will continue to sustain our unwavering efforts in producing relentless, creative, and innovative graduates. Thank you for being part of our journey. Here's to more years of energizing futures.
Applied chemistry is in our everyday lives. We see chemistry in almost everything. For example, the air we breathe, the food we eat, and even the fuel that powers up our cars. Chemistry is important because we see it in our everyday lives, and everything we observe is due to chemical reactions. My best UTP experience, I developed a catalyst to convert carbon dioxide into methane. And aside from my FYP project, I also managed to lead student organizations such as the Society of Petroleum Engineers student chapter, where I was elected the Deputy Vice President.
I did my 7 months of internship at Japan. The experience is really amazing and really great. I'm doing the research is regarding about the deep utility solvents using as a catalyst or as a co-solvents as well to enhancing the biodiesel production.
Chemistry is an important part in any future industry. Thanks to UTP's strong industrial linkages, as well as the wide range of expertise, I can apply what I've learned in the industry.
Backed by strong ties with Petronas, the parent company of UTP, the graduates from this program is able to tap onto that opportunity and enter into the oil and gas industry in Malaysia. The content of the program allows some level of versatility for the graduates to explore beyond the oil and gas industry in Malaysia. So it pushes the boundary to explore all other job options available in the country and also regionally and also internationally. So that makes the UTP graduates high-value graduates.
Mental chemistry. They also will be doing some computational chemistry. So after the 3 years, they will do a specialization package where they can do research projects. So in this research project, they can do either in environmental, they can do in catalysis, they can come up with new materials that can reduce pollution. After they have done this research, we believe this will equip them to go into the job market In Malaysia, a lot of companies are looking into chemistry who has knowledge in this area. So we believe in UTP, we will prepare the students for this job market that is not only today, but will be useful in future.
UTP Applied Chemistry program received prestigious accreditation from the Royal Society of Chemistry, or RSC, positioning the program to be internationally recognized. This provides assurance to employer and students in a competitive global job market. The RSC recognition also gives opportunity The Applied Chemistry program in UTP also offered 3 specializations, namely petrochemistry, sustainable chemistry, and nanotechnology, to cater for the Industrial 4.0.
The youth is important in Malaysia, and it's very important for us to ensure that they can participate in Malaysian well-being. So besides securing a job, we want to also get the students involved in the nation's issues, especially in environment, in pollution, in coming up with alternative energy. In UTP, we believe our course is preparing the students for these areas. When the students make a discovery in the lab, especially in their final year research project, we ourselves as a lecturer for past 21 years, we feel the honor to see the light in their eyes when they find a discovery. So, and many times these students have made useful discovery, which we are using it for our research project in later years. Coming to UTP is a good step for our youth to take up especially the applied chemistry course which we are offering here. Join us. Together we can dream up new possibilities.
To those of you who have come in search of answers, seeking inspiration and looking to achieve your aspiration, this is the place where you will learn to find the answers, where you will be motivated to discover your inspiration, where you will be propelled to realize your aspirations. With today's global challenges, the role of the into being the agent of global change. Our world-class resources and faculties, our cutting-edge facilities, our global partnerships with leading universities, our strong network with industry for internships and job placements, our worldwide research collaboration. These are the inspirations and the opportunities at UTP. Here, we nurture the analytical skills and intellectual capabilities of all who walk the UTP path. Here we culture the ethics and the attitudes that will shine in the real world. Here we expose ourselves to what it truly means to be human, to be a valuable part of society, to be the empowered people, the game changers who will light up the path towards a better world and change lives for the better. At UTP, the torch is firmly in your hands. So hold it up high and let us together light it and let it burn brightly. Join us to seek inspiration and achieve your aspiration towards global prominence.
How you doing?
Hi.
Months. I'm working on composite manufacturing, so I've been given a chance to work in the composite laminating room. Currently, composite manufacturing departments would like to implement a new technology into the composite laminating, whereby they use the laser positioning technology to reduce the time needed to manufacture this rooftop wishbone.
First time you working with CAD? Or
No, I learned some bits, pieces in university.
What can you take home with you?
Yeah, definitely is the teamwork. Yeah, and they help me to develop my skills bit by bit.
Excellent. Well, I hope your experience here has been great. And
yeah, it's great.
Hope the next 2 months you learn a huge amount so you can take back with you.
Yeah.
And you'll always be welcome back.
Yeah.
All right, buddy.
Nice to meet you.
And you. How you doing? Excellent. What have you been working on?
So I've been working in aero inspection, mostly because my supervisor Michael Fuller is in charge of that. So what we do is inspect all the parts before it goes to the model shop. I'm using like scanning equipment to scan the parts, also manual checks on the car.
So do you know what you want to do though in the future?
Not really.
Not yet.
I still have 1 more year to decide.
Okay, excellent.
Yeah.
Excellent. What's your favorite part of the Formula 1 car?
It has to be the front wings because they keep on changing it in the aero to make it faster and faster.
You're over in the by the wind tunnel. All those guys are the best.
Yeah, I've seen you a few times there.
Yeah, I like going there, and I'm going to go there today as well. I like to just go and see what's happening with the car. I might see you there later on anyways.
Yeah, I think so.
Excellent.
Catch you later.
It's a place that gives me opportunity for higher education.
I feel that this university is a very vibrant place. It's just amazing.
World-class education system.
What comes to my mind is above expectation.
Having graduated is also yet another memory.
Most memorable experience for me was
there are many good friends that I still keep in touch with and I still have to. I think these days are more than just knowledge and skills and career, thinking about future. Like college days is really something that's shaping your life.
My most memorable experience, we have this like a family of our I think it was 7, 8 of us, very close. So all of us are still in touch until today. I'm going to have
I'm outdoor and spend a lot of time on kayaks and the lakes around here.
I think my most memorable experience was when I was given a task to motivate and teach thousands of new students the UTP song during the orientation week.
UTP is very special to me because I come from a very humble background. Thinking of stepping into a university has always been quite a far-fetched dream.
Place that that teach me the analytical skills, the skills that is needed so much in my life.
My years at UTP were some of the best in my life. I walked into the real world as a UTP graduate feeling extremely confident.
What I like most about UTP is it's a melting pot of cultures. Particularly the environment here is very nurturing, very good for education actually.
if there's no classes, we'll go to Ipoh. You know, like that is an experience and a memory for us as well.
We download Korean drama from another I don't know where. Then so we just watched Korean drama because nothing to do in Toronto.
I created and organized UTP's major events that have now become the university's annual functions.
2019, I won the prestige 40 under 40 award. I must say that that award was given because of contribution towards different areas. So how did I get into this part instead of just focusing on engineering is because of my experience in UTP, where I was exposed to social developments through CSR programs.
Just like how I did with my IT, whatever I do up until today, I designed everything. If you look at kindergarten, I designed it. If you look at the school, I designed it. So I'm proud to say I'm the product of UTP. At least I bring that with me.
My advice to UTP students: first, explore all possibilities. Then identify your passion, what you really want, work on it.
Do well, up your performance. Most importantly, be passionate about life. Find the purpose and meaning in your life as you will venture out in your working life later.
To all UTP students and graduates, I just want to let you know how proud I am to be a part of the family. May we always keep up the tradition of being resilient, creative, and excellent.
Thank you, UTP, for unlocking the potential in me and shaping.
For 25 years, UTP has played a significant role in taking the nation, industry, and society forward. As we eye a greater shared future, our graduates, stakeholders, and community are in line to be the makers that push reality-defying growth and innovation. Welcome to our 25-year story of energizing futures. As a result of our 25-year experience, our well-rounded graduates and global citizens embrace the power of initiative to excel in the most demanding UTPians pave their success by making meaningful contribution to global industries as leaders of current trends. Based by our strong industry network, this gives UTPians a competitive advantage that gets them career ready even before they graduate.
UTP gave me the opportunity to really test myself and expand my horizons. Through my experience in UTP, I organized multiple volunteerism events, one of which even took place in Vietnam. From the moment you join UTP to the day that you graduate, that experience is one that will benefit you. It will change you as a person, whether you're a student or whether you're a staff. And these experiences give you lessons that will be embedded in you throughout your whole life, hence UTP in me.
As the world moves rapidly, UTP strives to be a leader in technology and education, as well as a center of excellence for creativity and innovation.
I think the most memorable experience is how we, the students, work with the lecturers and staff to pioneer new things. During my time, there was no clubs or student activities yet. So we started organizing activities, setting up clubs, and so on. We built the platform together, so to speak. Those are invaluable experience for me. When you don't have it, create it.
Research and development, R&D, is one of UTP's flagship core drivers. It has become a familiar hallmark of progress and prestige for the university. For 25 years, UTP's R&D activities have constantly returned many tangible benefits to the nation, industry, and society.
When you have that 8-month period, companies and also the leadership team of that place where you're interning in are more likely to give you projects. So everywhere I've gone, they all say, wow, UTP internship program, #1, the best. And I agree. Without that 8 months exposure, I do not think I could have as easily, I wouldn't have been as ready for the industry right after graduation. And just to share, less than 1 month after my graduation, I did manage to secure a job as a reservoir engineer at ExxonMobil. And what the feedback that I got was that, it seemed that I was very prepared to join and
happy anniversary UTP, and thank you for all these amazing 5 years and for all the opportunities and chances that you have given me.
And partnerships with the industry. Together with our partners, we edge towards sustainable global prominence, a unique feature of our global prosperity action and identity.
UTP is not just a classroom, but a real-life, career-integrated learning environment. It allowed me to explore what is the true potential within me.
I am glad that I managed to continue my passion in rugby sports that I've played since I was 16 years old and became the team captain for UTP G Drillers Rugby Club.
From organizing the event, being the MC in the concert hall, leading the International Student Representative Council, managing a football team, forming a music band with friends and competing at the national level, to representing the university for the petroleum engineering quiz competition. Who would believe that it all would happen in just a few years in UTP?
When we developed this university some 25 plus years ago, we call it a dream. The dream was to have the best engineering school in this part of the world, to produce students with holistic education so that they can contribute to the future success of themselves, their careers, and ultimately to the global good of the world. So it was a big dream, and the dream continues. Let's carry on with the good work. Let's continue with all the things that we believe in, and God willing, success will be achieved.
Seek to create. In this respect, we will continue to sustain our unwavering efforts in producing relentless, creative, and innovative graduates. Thank you for being part of our journey. Here's to more years of energizing futures.
Applied chemistry is in our everyday lives. We see chemistry in almost everything. For example, the air we breathe, the food we eat, and even the fuel that powers up our cars. Chemistry is important because we see it in our everyday lives, and everything we observe is due to chemical reactions. My best UTP experience, I developed a catalyst. Student chapter where I was elected the Deputy Vice President.
I did my 7 months of internship at Japan. The experience is really amazing and really great. I'm doing the research is regarding about the deep utility solvents using as a catalyst or as a co-solvents as well to enhancing the biodiesel production.
Chemistry is an important part in any future industry. Thanks to UTP's strong industrial linkages, as well as the wide range of expertise, I can apply what I've learned in the industry.
Backed by strong ties with Petronas, the parent company of UTP, the graduates from this program is able to tap onto that opportunity and enter into the oil and gas industry in Malaysia. The content of the program allows some level of versatility for the graduates to explore beyond the oil and gas industry in Malaysia. So it pushes the boundary to explore all other job options available in the country and also regionally and so internationally. So that makes a UTP
In our applied chemistry course, for the first 3 years, the student will be doing fundamental chemistry. They also will be doing some computational chemistry. So after the 3 years, they will do a specialization package where they can do research projects. So in this research project, they can do either in environmental, they can do in catalysis, they can come up with new materials that can reduce pollution. After they have done this research, we believe this will equip them to go into the job market. In Malaysia, a lot of companies are looking into chemistry who has knowledge in this area. So we believe in UTP, we will prepare the students for this job market that is not only today, but will be useful in future.
UTP Applied Chemistry Program received prestigious accreditation from the Royal Society of Chemistry, or RSC, positioning the program The RSC recognition also gives opportunity to students and academic staff. The Mobility in Exchange program among the RSC accredited institutions worldwide. The Applied Chemistry program in UTP also offered 3 specializations, namely petrochemistry, sustainable chemistry, and nanotechnology, to cater for the Industrial 4.0.
The youth is important in Malaysia, and it's very important for us to ensure that they can participate in Malaysian well-being. So besides securing a job, we want to also get the students involved in the nation's issues, especially in environment, in pollution, in coming up with alternative energy. In UTP, we believe our course is preparing the students for these areas. When the students make a discovery in the lab, especially in their final year research project, we ourselves, as a lecturer for past 21 years, we feel the honor to see the light in their eyes when they find a discovery. So, and many times these students have made useful discovery, which we are using it for our research project in later years. Coming to UTP is a good step for our youth to take up, especially the applied chemistry course which we are offering here. Join us. Together we can dream up new possibilities.
To those of you who have come in search of answers, seeking inspiration and looking to achieve your aspiration, this is the place where you will learn to find the answers, where you will be motivated to discover your inspiration, where you will be propelled to realize your aspirations. With today's global challenges, the role of the engineer, the scientist, and the technologist is transformed from being the technical innovator into being the agent of global change. Our world-class resources and faculties, our cutting-edge facilities, our global partnerships with leading universities, our strong network with industry for internships and job placements, our worldwide research collaboration. These are the Here, we nurture the analytical skills and intellectual capabilities of all who walk the UTP path. Here we culture the ethics and the attitudes that will shine in the real world. Here we expose ourselves to what it truly means to be human, to be a valuable part of society, to be the empowered people, the game changers who will light up the At UTP, the torch is firmly in your hands. So hold it up high and let us together light it and let it burn bright. Join us to seek inspiration and achieve your aspiration towards global prominence.
How you doing?
Hi, great.
What's your name?
Kang.
Kang.
Nice to meet you.
Where about you? From Malaysia, right?
Yeah, I'm from Malaysia.
Excellent. How long have you been here?
About 4 months. I'm working on composite manufacturing, so I've been given a chance to work in the composite laminating room. Currently, composite manufacturing departments would like to implement a new technology into the composite laminating, whereby they use the laser positioning technology to reduce the time needed to manufacture this retard wishbone.
First time you working with CAD? Or
No, I learned some bits, pieces in university.
What can you take home with you?
Yeah, definitely is the teamwork. Yeah, and they help me to develop my skills bit by bit.
Excellent. Well, I hope your experience here has been great. And
Yeah, it's great.
Hope the next How you doing?
Hi, nice to meet you. My name is Praveen.
Previn, nice to meet you.
Yeah.
How's your stay been?
It's been great so far.
You've been here for 4 months, right?
Yeah, since January.
Excellent. What have you been working on?
So I've been working in aero inspection, mostly because my supervisor Michael Fuller is in charge of that. So what we do is inspect all the parts before it goes to the model shop. I'm using like scanning equipment to scan the parts, also manual checks on the car.
So do you know what you want to do though in the future?
Not really.
Not yet.
I still have 1 more year to decide.
Okay, excellent.
Yeah.
Excellent. What's your favorite part of the Formula 1 car?
It has to be the front wings because they keep on changing it in the aero to make it faster and faster.
You're over in the by the wind tunnel.
Yeah,
all those guys are the best.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon I bid to everyone. Hello everyone. I hope you all had a good lunch and a break time just now. Welcome back to NICC 2.0. My name is Nubatisha Akila and my partner,
My name is Muhammad Hafiz Fahmi.
and we will be your host for this afternoon session. Ladies and gentlemen, we will now start with our mini game session using Flexi Quiz. In this session, the participants are going to be categorized into two categories, which are undergraduate UG and postgraduate PG. There are going to be three winners who will stand a chance to win interesting prizes for each categories. But firstly, how do we conduct the session, Hafiz?
Okay, for this session, we will start with undergraduate quiz, which is there will be 10 questions in total. You may join the game through the link provided in the YouTube live chat UG category. As you can see in the slide right now, we have the QR code for the undergraduate session. You may scan and join. Kindly reminder, this is only for UG students, and finalist students are not allowed to join. Thank you. Our, our remaining games, the UG sessions QR code for the quiz is already been displayed on the slide. Or you also may enter the code for 5652543. We will wait for two.
Let's join the game as great prizes are prepared for all of you.
As I already mentioned just now, this is only for undergraduate students, and finalist students are not allowed to join. If we detect any finalist students joining the UG session quiz, you will be automatically disqualified. Thank you.
Okay, let's start the game now. I hope you guys are ready. If you listen attentively throughout the presentation of the undergraduate students, the quizzes will definitely be as easy as ABC for you guys. Question number one. John's reagent used for the treatment of sponge was made up of. I believe these came from our first contestant of today's presentation in the morning session. For each question, we have 30 seconds allocated, so you have supple time for you to choose the answer.
And for the second question, which of the following are significant for CO2 saved for in industry process? We have 4 choices. We have natural gas returning, biogas upgrading, oil recovery enhancement, and landfill gas purification. You may think for a while and then answer as soon as you can. The fastest you answer, the highest the mark you will be obtained. 4, 3, 2, and 1.
Question number 3. The roughness of the CQD modified polysulfide membrane can be measured using, is it the AFM, is it AAS, is it EDX, or is it the XRF? Couple more seconds for you guys to guess and answer. 4, 3, 2, and 1. The answer is AFM. Proceeding to the next question.
The question number 4. Is it Cooper nanoparticle have antiviral properties? Is it true or is it false? If you listen carefully throughout the presentations, you will be definitely answer the question correctly. Thank you.
Let's proceed to question number 5. 1.58 million tons of fiber waste are generated from palm industry annually in Malaysia. Is it true or is it false? I'm pretty sure this question is quite straightforward, so you just need to choose either it's true or either it's false. Last 10 seconds for you guys to answer. 5, 4, 3, 2, and 1. Next question, number 6. The followings are the advantage of organic polymer solar cell, except for, is it low material toxicity, or is it because it is economical? Is it due to not using halogenated solvent, or is it because it has less impact on the environment?
And for the next question,
okay, question number 7. What type of sportswear that is high quality? Does it have to be a heavyweight, expensive, non-elastic, or is it comfortable? Perhaps it can be because it's comfortable, it is high quality, but perhaps can it be expensive as well? Last 2 seconds for you guys to answer. 3, 2, and 1. The answer is comfortable. Proceeding to next question.
and for the next question, the question number 8, outer layer of banana peel is antimicrobial. Is it true or is it false? I think this already been presented by Pishang Lab. I think everyone can answer it correctly. Okay, for the question number 9, the bio nanocomposite are hybrid nanostructure material based on synthetic polymer with enhanced functioning and structural properties. Is it also have 2 options? Is it true or is it false? You have 10 seconds to answer the question.
Moving on to the next question. The followings are 3 phases of PVDF except for gamma, beta, delta, or is it alpha? What a game for the UG category. With that, that's the end for undergraduate category quiz session. And now, ladies and gentlemen, we are going to proceed with postgraduate quiz session. There are going to be 7 questions in total, and you can join the game by searching Flexi Quiz through the website and key in the code displayed on the screen, which is 817-5817. We are not going to display the winners for the undergraduate category session, so you have to wait for the prize giving ceremony by the end of this session this afternoon. We will now move on to PG session, postgraduate category session quizzes. Okay, you can just scan the QR code displayed on the screen. It will directly direct you into Flexi Quiz, and please key in the code of 817-581. Great prizes are prepared for the top 3 winners. So let's join the game. I'm sorry.
Attention to all the audience and also participant. Please write your full name, 817. Thank you.
Dearest viewers, if you would love to join the quiz session, please enter your full name as it will ease this process of tracing the winners for this quiz session. We're going to wait for a couple more minutes, another 1 or 2 minutes for you guys to join, and we will start the quiz session soon.
Are you guys ready? Let us all have a fun in the postgraduate session.
Luck.
For question number 1, gamma radiation enables the graphing of specific monomer into the base polymer. Is it true or is it false? You may answer this question as quick as you can. For information, the fastest you answer, the highest mark that you will be obtained. The remaining 5 seconds, 4, 3, 2, and 1.
For question number 2, the following are method deployed to dispose palm oil biomass waste except for converting it into organic feed and fertilizers, landfill site wash disposal, or is it sea dumping process, or is it the another answer? You have 30 seconds actually for one question, so make sure that you answer it correctly so that you can win the prizes that we prepared for you. Last 2 seconds. And let's move on to next question.
And for the question number 3, the synthesis of MIP has 2 steps. Step 1, polymerization, and step 2, cross-link polymerization. Is it this statement is true, or is it false? As your information, all the questions that been asked in the quiz has been presented during this morning session. And for the next question, question number 5. For the question number 5, the aloe vera gel contains the following, except there are 4 choices for you guys to answer this question. We must remember, except, not the true one. Alright, the remaining for 10 seconds. 9, 8, 7, 6, 5. Yeah, the answer is polyaromatic substance. Moving on to the next question.
Which region has the highest estimated number of face masks used per population during COVID? Is it Europe, Asia, Africa, or South America? Wow, that was quick. Next question.
And for the last question, antiform or deformer is a chemical or is it true? This question only have two choices, so I think your post.
That was so quick, right, Afis? I hope the game session was fun and entertaining for all of you who joined. Thank you so much for joining in, but unfortunately, game session. But what about you, Hafiz?
Yes, it was fun session for me too. I hope everyone also enjoyed the fun time together with us just now. But Risha, I think it is the right time to announce the winner for NICC 2.0, right? Before we announce the winner, I would like to acknowledge and sincerely appreciate the participation and the commitment of the judges who came here and adjudicate the competition with wisdom and honesty. Thank you very much for your dedication.
Hafiz, I am so excited now to announce the winners. Shall we spill the tea now? Oh, my bad, the prizes. Okay, but before I announce the prizes, can I get some reaction for the contestant? I believe you guys are excited to know the winners, to know if you win. But before that, can I get some reaction? Thank you so much, ladies and gentlemen, for your kind information. These are going to be the prizes amount for each winner, which might be one of you here. For undergraduate category, consolation prizes will win 250 ringgit Malaysia. Second runner-up will win a cash prize of 500 ringgit Malaysia. First runner-up will be granted 750 ringgit Malaysia. And last but not least, the first prize, aka our grand winner for today, will bring home cash prize worth of 1,000 ringgit Malaysia. Wow.
Wait. That is so amazing. I think everyone are even more excited now, right? After hearing about the money, right? So without wasting any more time, let's proceed to the winner announcement.
Starting from undergraduate category, there are going to be 3 consolation prizes winners, and the teams are. Congratulations to Sally the Dark from University Technology Petronas. Maybe we can use the reaction of applause for them. Congratulations. And the second team who won the consolation prizes goes to Team Hexagrow 2.0 from Taylor's University. Congratulations. And last but not least, the third team that will win consolation prizes, bringing home 250 ringgit Malaysia, goes to. Which group do you think it is? Team UKM from University Kebangsaan Malaysia. Congratulations to all the teams.
Moving on to the third place for undergraduate category, winning 500 ringgit Malaysia goes to. Congratulations to Polymer Preachers from University Malaya.
Now, it is time to call upon the second place winner.
Who do you think will bring back 750 ringgit Malaysia from this event, Patricia?
I'm not sure, but let's see. Let's give us a round of applause to our second place winner, which is group Pisang Lab. Congratulations on their innovation.
Patricia, are you excited to know who the champion for NICC 2.0 for the undergraduate category?
Of course I am.
All right, ladies and gentlemen, this is the moment of the truth. The champion for the NICC 2.0 for undergraduate category, winning the grand prize of 1,000 ringgit Malaysia, goes to Tanoff from University Malaya. Once again, congratulations to Tanoff.
Congratulations to all the winners for undergraduate category. Ladies and gentlemen, let's move on to the prizes for postgraduate category, which is even more exciting. For postgraduate category, consolation prizes will bring home 375 ringgit Malaysia. Second runner-up will win a cash prize of 1,000 ringgit Malaysia. First runner-up will be granted 1,250 ringgit Malaysia. And last but not least, the first prize, aka the champion, will bring home a cash prize worth of 1,500 ringgit Malaysia. Now, let's welcome our consolation prizes winner, which goes to the group. Which goes to Fabulous Fibers from USM. Congratulations! Next, our consolation prizes winners is Alchemist from University Putra Malaysia, UPM. Congratulations! And last but not least, the consolation.
Moving on to the third place, they're bringing home 1,000 ringgit Malaysia, goes to Provera from UMS. Congratulations. But can you announce the first runner-up winners?
Yeah, sure. Everyone, let's give a round of applause to our first runner-up that goes to Divas from University Technology Petronas, UTP. Congratulations! Hafiz, I am so getting excited right now. Shall we do a grand prize winner for this PG category?
Yes, as we already know, the first prize will bring back 1,500 ringgit Malaysia. But Risha, who do you think will be the winner today?
I'm not sure because everyone performed very, very well, but I'm just so excited to know the result. You better announce now.
Alright, so without wasting any more time, the winner for the NICC 2.0 postgraduate category goes to the group MKO Group from Unimas. Congratulations.
Wow, that was so thrilling. We would like to congratulate all the participants for giving your highest effort and commitment in the competition. Next, let's move on to mini game session that we just finished just now. There are going to be 3 winners for each undergraduate and postgraduate category. Do you guys want to know the prizes? If you would love to know the prizes that will win, can you Ladies and gentlemen, the prizes for mini games session just now for undergraduate category. Third place will bring home 25 ringgit Malaysia. Second place will bring home 50 ringgit Malaysia. And first place will bring home 70 ringgit Malaysia. On the other hand, for postgraduate category, third place will bring home 30 ringgit Malaysia. Second place will bring home 55 ringgit Malaysia. And the winner or the first place will bring home 75 ringgit Malaysia. I think that is more than enough to buy McDonald's Happy Meal set. Hafiz, would you like to announce the winner for undergraduate category?
Yeah, sure. For undergraduate category, the third place goes to Ma Wen Huai. Alright, so my mistake. So I would like to announce again for the undergraduate category winner for the quiz session. So for the third place goes to Nick Abdul Hazim. And for the second place goes to Chang Jiang Heng. And for the first place goes to Ma Wen Huai. Good game, everyone. So Batusha, I think it's now your turn to announce for postgraduate category. I pass the button back to you.
Yes, sure. I apologize on behalf of my partner on the mistakes just now. Let's move on to the postgraduate category minigame session winner announcement. The third place for postgraduate category goes to Nadia. Congratulations, Nadia. But we would love we would appreciate if you actually put your full name. And the second place goes to Noor Shafika. Congratulations. And with a score of 6 out of 7, the winner for postgraduate category goes to Chang Jia Heng. Congratulations, everybody.
Congratulations again to all the quiz winner. Before that, for the quiz winner, please be informed that you need to send your details such as full name, phone number, category, and university to Felicia 2200196 5_utp.edu and .my. Thank you.
I apologize on the mistakes because we were strict on the rules that if the name is not full name, then the participation will be disqualified. So the postgraduate winners are as displayed on the screen. I apologize once again because we already put the rules that those participants for the mini game session who did not put their full name, they will be automatically disqualified. Thank you, everybody, and I'm sorry on the confusion.
Wow, that's amazing. Congratulations to all the quiz winner. Before that, for the quiz winner, please be informed that you need to send your details such as full name, phone number, category, and also university to Felicia _22001965 ACS-UTP.edu. phone number, category, and university to Felicia_2201965@allianceuTP.edu.my. Thank you.
Ladies and gentlemen, with all due respect, we are going to re-announce again the undergraduate category winners for minigame session as well as the postgraduate category. So the third place for undergraduate category minigame session goes to Tan Chi Huan. Congratulations. And the second place goes to Nick Abdul Azim. And the first place with the highest score goes to Mahwern Hui. Six out of 7 score goes to Chang Jiang Heng. Congratulations. Time flies super fast when you are just having fun, having a leisure time. But it is not going to be a complete event if we do not hear from our main backbone. Hence, with all due respect, I would like to invite the Project Director of NICC 2.0, Ms. Anis Izana, to appeal and deliver her speech. Please welcome.
Bismillahirrahmanirrahim. Associate Professor Dr. Jafrizal Jafar, Dean of Faculty of Science and Information Technology, University Technology Petronas. Dr. Muhammad Syukur Suai, Chair of American Chemical Society. UTP Student Chapter. Mr. Muhammad Faisal Tahar, Project Manager of ACS-UTP NICC in Chemistry Challenge 2.0. Participants of ACS-UTP NICC in Chemistry Challenge 2.0, respected representatives from universities, distinguished judges and guests, beloved students, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh, Salam Sejahtera. A very pleasant afternoon to all of you. It gives me great pleasure being with all of you today in the NICC in Chemistry Challenge 2.0, a continuation from NICC 1.0 last year. Firstly, I would like to extend a note of thank you to everyone for becoming a part of this event and gracing it with your presence. I, Anis Izana, on behalf of my committee members, want to sincerely acknowledge the efforts of those who came forward and contributed to the success of this event and making it this grand. We grow and prosper because of your dedication and commitment put into your individual as well as your group goals. All this wouldn't have been possible without the support of all the authorities. NICC in Chemistry Challenge 2.0 with the theme of Polymer Fibers aims to inculcate innovative traits and communication skills among the undergraduate and postgraduate students in the Southeast Asia region as well as around the world in conjunction with celebrating the 25th anniversary of UTP and also the National Chemistry Week 2022, which promotes the importance of chemistry in everyday life by raising the public awareness. For your information, in this year, we have received participation from 10 Malaysian universities, 2 Indonesian universities, and 1 Hungary university. It's great to see many teams taking chance and participating in this competition. Ladies and gentlemen, chemistry is a topic of study that is highly intriguing and sometimes referred to as the core science because it joins together physics and mathematics, biology and medicine, and the earth and environmental science. Chemistry plays a role in everyone's life and brings impacts on practically every element on it. Chemical technology enrich our quality of life in various ways by providing new solutions to problems. Understanding the nature of chemicals and chemical processes provide valuable insight for us into creating a sustainable world. Increasing concern among the public about the rational utilization of chemistry is significant, and only through a joint effort we will be able to accomplish this goal. Therefore, today, different prospects of fabrics and polymers of the chosen problem statement, which in line with the theme, will be presented, and there will be knowledge sharing from the wide aspects of fabric and polymer in the professional chemistry field. We will have the opportunity to tap into the knowledge and expertise of everyone who is present here. Critical discussion is required for basic ideas to flourish. In this regard, I believe and hope that this event will play a transcendental role in the convention's future. Once again, goes to Dr. Cecilia and Mr. Faisal. Without their assistance and advice, this event would not have been possible to arrange. I sincerely hope that our event would be a worthwhile opportunity for better interaction, networking, and dissemination of knowledge. Finally, my sincere gratitude to NICC committee members for running a smooth event and making it a success. Thank you.
Thank you, Ms. Anis Izana, for your amazing and inspiring.
I would like to thank all the officials and participants for the engagement we had today.
Hafiz, I think you forgot something that we can keep as memory.
Oh, yeah, I forgot about the picture. So let us have a quick photo session with our audience as the memories and appreciation for everyone's support here. Ladies and gentlemen, you are kindly invited to open your webcam so that we can be in a frame together. One row, can you help me by in charge the photo session? Thank you.
Yeah, sure. Thank you. So please, everyone, please open your webcam.
Let us all join the photography session together.
So, okay, in 3, 2, 1, snap. Yeah. Okay, one more we take for freestyle. Okay, so in 3, 2, 1, snap. Okay, thank you. Thank you so much.
Nice picture, everybody. With that, it marks the end of NICC 2.0 with ACS-UTP International Student Chapter Committee. You know, Hafiz, I feel a bit sad as we are approaching the ending now.
Yes, me too, Badisha. However, every beginning must come with an end. So congratulations once again to everyone. We would like to sincerely apologize if there were any mistake and inconvenience throughout the event.
We hope that all of you are able to gain benefit, to gain new knowledge and experience from the next In Chemistry Challenge and share the knowledge and latest information with your friends at your respective universities. But before we end, please kindly fill in the feedback form by clicking the link provided in the chat box, or you may also scan the QR code that is displayed on the screen so it will directly direct you into the feedback form. Your feedback really matters to us for the improvement in the future. Thank you. Thank you for your cooperation.
Attention to all the audience, the picture that have been snapped just now will be provided at the chat box. You may get it in the chat box. Thank you. Hello everybody. I hope everyone can leave your feedback by scanning the QR code that appears on the slide right now. Your feedback really matters to us for the improvement. Good day everybody. We will meet again. Bye bye.
Thank you, everyone. Have a nice day. Bye. Congratulations again for the winner. See you guys in the next event. Assalamualaikum warahmatullahi wabarakatuh. Bye.